All right. We have like 2 more slides, or 1 slide and a summary, something like that. So breaking and continuing a loop. If your code's running in a loop, but you need to stop the loop early, you can do that. We've already seen that. I'm pretty sure we've used a break statement several different places. If your code needs to instantly begin to the next iteration of the loop without completing, like it's halfway done with its task, but nope, I'm going to start doing the next thing I need to do, you can also do that. Different keywords called continue rather than break. So kind of like this, right? We have a while true loop. We're just running forever.
Are you recording?
Oh, I hope I am. Yes, I am. All right, so while true. And all we're doing is adding numbers. Well, we can make it a for loop, right? For int I is equal to 0, I is less than 100, I plus plus. We have decided, for some reason, that we're going to let the user kill this application early. So we might ask them, do you wish to stop? Continue? Yes, no. And we ought to probably be entering this inside, Visual Studio. And we get that in, right? And if repeat is equal to no, they want to stop. Else we're going to do whatever we're going to do with I, right? We may calculate some magical value, right? And z is equal to I times I, print z, whatever we're supposed to do. But then later on we decide that for all values of I that are evenly divisible by 3, we don't want to do these next steps. We don't want to do that and then print it out. And yeah, why don't we just do this inside of Visual Studio? So we're on U, if my reckoning is correct.
Yeah.
Add a new source file, lectureu.cpp. Paste my boilerplate into it. All right, going to write a loop. All it does is print a number and then ask the user if they want to continue. Except it's going to do it in the opposite order. It's going to ask them if they want to continue. We can do it in this order that I just said. And for some reason, we've chosen to implement it as a while true, lowercase t, rather than putting in some kind of priming read and basing it on that as our loop control variable. So we need some counter. And didn't I just say we were going to use a for loop rather than a while true? Yeah. Delete that while true. For parentheses, int I equals 0. How about x? X is easier to read on the screen than I. X is equal to 0. X is less than 100. X plus plus. So we're going to print out. We're going to use the value of x for something. Cout, arrow, quote, x cubed equals, end quote, arrow, x times x times x, arrow, ENDL. Just to be doing some kind of work with our counter variable. Now we're going to ask the user if they wish to continue. string s, cout, arrow, less than, quote, continue, y/n, space, angle to tell them where to type, close quote, semicolon. And then cin, arrow into s, and if s is equal to no, they no longer want to repeat. So, if, just let me finish typing those three things before I forget. If s equals no, end quote, in parentheses, next line break. Yes, ma'am.
What's that forward arrow for?
That's just a place to start typing.
Oh.
Let me show you what it looks like when it runs. I just recently have decided that I'm going to make all my programs do that, and so I haven't been inflicting that too much on y'all yet. My fundamentals classes did it. Right? It's just telling us where to type. Nope, it's not a special thing. Not a special command. Good question. But we've also decided that on the rare moments that it's evenly divisible by 10, or let's just skip all even numbers. Now sure, we could modify our for loop to do this. But if x mod 2 equals 0, meaning it's an even number, we're just going to skip it. So open curly brace, cout, arrow, quote, skipping, end quote, arrow, x, arrow, ENDL. And then put the word continue here. Continue means don't do anything else in the loop. Immediately jump back to the top of the loop and keep running. Kind of like a break, except a break exits the loop and continue, so it goes to the bottom of the loop and bails, whereas continue goes back up to the top of the loop and increments x, or whatever the increment step is, the update step is. Make sure it works before I brag too much about it. All right, x cubed is 1. Do we want to continue? Sure, why not? It skipped 2. All right, continue. Well, it did 2, and then it did x cubed is 27, so it did cube 3. Continue? Yeah, sure. It skipped 4, and then it did 5 cubed. Right, so it's skipping every even number, and I'm sure we remember why, because something modulus 2, if it's equal to 0, there was no remainder, so it's an even number. We could change that so it only skipped every third, right? It's modulus 3. And it's going to keep repeating as long as we don't type no. Yeah, okay, it did 2, it skipped 3, it did 4, it did 5, it skipped 6, and so on. So you see what continue does. Continue causes it to immediately jump back up to the top, perform the update step, and then start running again. So when it hits continue, it doesn't do any of this business. And that can be useful. Why? Because you could have a loop, and then maybe you're asking the user for something, and then if they give you bad input, you could just immediately print out that message, continue, and jump back up to the top of the loop. That'd be a way to force them to enter good input. Handle your error condition by printing out the error message and then continuing. So that would look something like this. And again, you could do this differently, like with a priming read or something. While, parentheses, true, in parentheses, let's ask a question. Cout, arrow, enter a number, anything but 10, backslash, end quote, semicolon. And I put the arrows going the wrong way. My mistake. The arrows go towards the cout, less than. Now let's let them type that in. Int in, cin greater than n. And then we're going to check to see if it's equal to 10 because we told them not to. If n equals 10, Let's yell at them. See out error, error, quote. Weren't you listening? No 10. \n. And then continue. Helps if you spell continue correctly. Continue. Continue. All right. Now we might ask them if they want to repeat again, right? String S, C out, arrow, arrow, quote. Repeat, y/n. Did I do something wrong? Yeah, why am I stuck on the arrows going the wrong way? There we go. C out, less n, repeat, yn, space, space, greater than symbol. For some reason I didn't do the greater than symbol up there. So what? Greater than, end quote, and then semicolon, and then CIN, arrow, arrow, into S, and if S is equal to N, then we're going to break. Now we could avoid doing that break. We could write this as a do loop and keep repeating while S is not equal to N, right? Any loop you write with a break statement can probably be written without a break statement. But we're just demonstrating a concept so you can tuck it away into your brain, and if you find a legit reason to want to break out of a loop, you can. All right. So continue, sure, why not? Continue, continue. Okay, we're tired of that game. Enter a number, anything but 10. 9? Yeah, that was fun. 11? Yeah, that was fun. Keep continuing. 10? Weren't you listening? No 10. Right. So that's a legit reason to use continue. To rule out an error state. If there is an error state, you display your message or something like that, and then you immediately continue so you don't have to worry about doing the rest of this stuff or handling how you're going to do the rest of that stuff. Now sure, you could put an else clause and embed everything in there, but by the time you're handling like 4 or 5 or 6 different error states, you know, error conditions, and you're not using continue to force the reiteration of the loop, then the logic starts to look really ugly. Anybody got syntax errors I need to go eyeball? Anybody need me to keep it on this screen?
Just a second.
All right.
Can you roll up a little bit?
All righty. I will do so. You let me know when I can scroll up. Because she needs to? Okay.
I need to look at what's going on up there too.
All right, that's cool. There we go. And let me come over and help.
I'm not sure.
I guess technically there's one between these two, but I really want to start talking about arrays right now. Plus we've been doing functions quite a bit already. All right, what are arrays? Well, I mentioned classes last semester, not semester, on Tuesday. And what is a class? It's a group of data and the functions that act on it. And so the data can be of any type, right? You have a name and you have an integer for the age and, you know, stuff like that. Well, an array is another way to hold a set of data, but they're all data of the same type. And they're not just one entity, right? They're not just about one book or one person or whatever. It's like a series of prices or a series of ages or a series of names. So arrays hold multiple values. An array is a variable that can hold multiple values of the same type, They all have to be of the same type. Now, somebody argued with me, and they must have been a programmer, that you could store all data in a string and then convert that data to any type that you needed to. And yeah, technically that's true, but still, all the data is a type string in that case. You're just going to be treating it in different ways based on what's stored in it. So if you have an array of ints, the only thing you can store it is ints. If you have an array of strings, what you stored in is strings. And here's what's kind of important, is that the values are stored in adjacent memory locations. If you use Python lists, if you use Java array lists, this is not true, that they're stored in contiguous locations. Arrays are special. They are stored in contiguous locations, meaning that if you have 100 ints, then 400 bytes of your computer's RAM are dedicated to holding that array. It's all nice and contiguous. It can be summoned into your computer's RAM, your processor's RAM with a single, chip call. They can be cached so that the computer can, access that RAM exceptionally fast. Arrays are the fastest form of data structure there are. Now, lists, or vectors as they're known in C++, and Python lists and array lists and stuff like that, are all more convenient than arrays because they can grow and shrink, whereas arrays are fixed in length. Once we declare this array of length 5, it's going to be length 5. We're not going to be able to delete the second element from it. We can replace it, but we can't delete it. Then we can't append something to the end of it. Now, technically you can, but it's a complicated process. Why? You have to allocate a new array of 6 elements, copy all these elements into the new array, then fill in the 6th one, then destroy the old one, right? And now you have an array of 6. It's like having a trailer park with 5 arrays in it, 5 trailers in it, and then you want to add a 6th trailer to it. So you have to go and you have to, claim somebody else's land, tack on, the 6th trailer, move all the other ones into your new land, whatever. So, arrays are fixed in length, which can be a drag if you're used to using data structures in other languages, such as Python's lists that grow and shrink as you need them. They are all of the same type. Once we have declared this as an array of ints, then every piece of value in here is going to be an int. Also not true of Python, where if you feel like sticking an int followed by a string, followed by a float, followed by a boolean as members of the list, then that's totally valid. But Python's a completely different beast. So in this definition, int test subscript 5, that's the data type. The int is the data type. You could replace that with string or char or unsigned int or float or double, long. Test is the name of the array. And then that 5 is known as the size declarator, if I'm pronouncing that correct. I hope so. Declarator. It shows the number of elements in the array. Now, here's what kind of irks me, is that they say that the size declarator is this, and then they say that the size of the array is the number of elements times the size of each element. Okay. If I was writing these textbooks, I would say that this is the length declarator, that the array is 5 elements long. But then the size of the array in bytes. Is the number of elements times the size of each element. Yeah. Well, let's make an array and print out its size. And let's do it up at the very top of main so that we don't have to keep answering these questions before we get to the good stuff. Let's make an array of 4 ints. It's called nums. Notice the syntax is backwards for you Java guys who are used to doing this. Right, to make an array reference. Java just had to be a little bit different. However, Java does actually support this syntax. They just don't support sticking that number in it. Okay. We want to put a value in the first one. Nums subscript 0 is equal to 100. Now I'm going to put a value in the second one. Num subscript 1 is equal to 200. Num subscript 2 is equal to 300. When I say subscript, I mean the square brace followed by the number followed by the end square brace. The subscript is also known as the index. And a num subscript 3 is equal to, yeah, let's be weird, 500. Why did I number them 0 through 3? Because this is known as zero-based indexing. The first element is 0. It's still 4 elements. You can count them there, right? 0, 1, 2, 3. That's 4 elements. It's just that we start counting with 3. I mean, at 0. So you cannot get to element 4, or it's out of bounds. Now, this language will actually let you access past the end of the array. It may generate an error. It may not. Languages like Java and Python do some checking to make sure you're not checking past the end of the array. And what do I mean past the end of the array? If I added that, we created something only with 4 boxes. And then we're saying, yo, in the 5th box we want to put something. Actually works. It might give a syntax error, it might not. I'm going to run it and see if the debugger complains about it. It did not complain. Oh, and then it did. At the very end, the debugger said, oh, runtime check, the stack around the variable nums was corrupted. It caught the fact that there was some data corruption, that we wrote past the end of the array. If we compiled it in release mode rather than debug mode, if we pull this down and we changed it to release, and then we rebuilt it and ran it, debug start without debugging, it probably would not catch it. So, it's possible that some memory got corrupted and we didn't notice it. Now, really, the only memory that's getting corrupted is the memory that's owned by this process. So it's not like our program, by doing that, is going to crash the entire computer anymore. Back in the old days, before the operating system protected one program from modifying the memory of another, then yeah, you could crash the entire computer by writing past the end of the array. Still, it's something you don't want to do. Let me switch back into debug mode. So let's make a comment to the effect, and by the way, I'm tired of entering these loops, so I'm just going to stick a return 0 right there to stop it from doing those 4 loops. And I'm going to delete that line because it caused an error, or at least I'm going to comment it out. This would be writing past the end of the array. The array is 4 elements long, meaning we can access elements or subscripts 0 through 3. If we tried hard, we could write a program that would demonstrate that if we went past the end of the array, we would be changing other values in our program. We could be printing out the variables, you know, before and after we wrote past the end of the array, and we could spot one changing without us knowing about it. But we're not going to figure that out. Just take it on faith, please. Do not write past the end of the array. Well, how do you know if you're writing past the end of the array? We don't know how many elements there are in this thing. In a convenient language like Java or Python, we could ask the array how long it was. You can't do this, so don't even bother typing it. If x is less than the length of the nums array, right? That's good Python. Or in Java, if x is less than nums.length, and that's good Java. C++ does not have a way of determining the length of the array. We can hack a kludge, though. We can ask the array how long it is, and then figure out how many items are in it based on that. let's print out the size of this array. So cout less than size of nums array equals end quote arrow size of parentheses. I'm going to go to the next line. You don't got to do that. You have more smaller font than I do. Size of nums arrow quote space bytes \n. Oh, and since I stuck a return here, I better put my system pause there as well. I guess with the system pause, I wouldn't even need the return statement. All right. And so the size of the nums array is 16 bytes long. Why? Because an int is 4 bytes. It's a 32-bit value. 32 divided by 8 bits per byte is 4 bytes. So all we would have to do to calculate how many elements in the array is take the size of it and divide it by 4. Well, what if it was longs? Long, something like that. Well, they're not 4 bytes long. So here's how you calculate the length of an array. If you can, if you're in a place in the program where this works, and there are some places where it will not, int num underscore items equals size of parentheses nums close parentheses divided by size of either int if we know the data type, or if we don't know the data type, we could just take the size of the first element in the array. So I'm going to get rid of that int and I'm going to replace it with size of parentheses nums subscript 0. And I'm sorry that that looks kind of weird. It'd be more comprehensible if you just made that int. Oh, and it looks like I'm missing a close parentheses. If we print out num items, it's going to say 4. Because the size of the first element in it, since the first element is an int, that's 4. It was 32 bytes, no, it was 16 bytes long. Size of nums, we just printed out, it was 16, so 16 divided by 4 is 4 items, which is in fact how many we allocated. You don't have to do it that way if you just declare a constant that holds the size, which is a better solution. But we can calculate the size, the length of the array on the fly by doing that. Let's print that out and make sure it works. Cout arrow quote number of items in array is end quote arrow num underscore items underscore arrow ENDL. All right, the number of the items in the array is 4. Quite true, it is. But that's kind of going around our elbow to get to our face, or whatever the saying is, because we could have just said up here that we made that a constant. Like this. Let's define another array demonstrating that. Const space int space num underscore names equals 3. We're going to store 3 names in an array. Now let's allocate an array. So we need the data type, which is going to be string, followed by the name, followed by a square brace, and the number of items we want in it. So string space names, we could call it name array, but we called the other one nums, so I'm just going to roll with it. Names, subscript, and now I'm going to use my constant. Between the square braces, I'm going to put num underscore names. Now I don't have to mess with this size of business to know how many items are in it. Well, why do I care how many items are in it? So I could write loops to go through it, print them all out, add up all the numbers, something like that. Let's print out all of our names. Oh, by the way, compile it, make sure there's no syntax errors at this point. I'd rather not go much further. Of names, and we have an array of nums, but we didn't put any names in there. Well, let's put some names in there. Names, subscript 0 equals Gilligan. Name, subscript 1 is equal to Skipper. And name, subscript 2 is equal to Mr. Howell. Or we don't want to leave the women out, Ginger. There we go. So let's print out our number array for parentheses int I, for int, short for index, equals 0, semicolon. I is less than the number of numbers, which we decided was called num items. So I is less than num underscore items, semicolon, I plus plus. Let's see out that array element, see out arrow arrow nums subscript I, in subscript, and an arrow arrow followed by a space or a comma. Yeah, a space will do. Notice I didn't put an E and DL there. I just want all the numbers to be lined up one after the other on the same row. But if that's true, then I need to write out an E and DL after the loop. And do the names the same way, except it's not going to be num items, it's going to be num names. So for parentheses int I equals 0, I less than num underscore names, semicolon, I plus plus, see out arrow arrow names subscript 0. Now let's make this one look a little bit fancier. Changing my mind on this one. I'm going to use a curly brace here so I can put a block of code. And we're going to write out the index number and the name. So see out arrow arrow quote names, how about just name, space, end quote, arrow arrow I, arrow arrow quote, space is, in space, end quote. I went to the next line, you don't have to. Arrow arrow names subscript I, in subscript arrow arrow E and DL. What's the difference? The first one, the numbers are being printed out all on one line, and we're waiting to hit the carriage return, the enter key, after the loop. The next one, we're printing both the index number and the value of it on the same line, and then we're going to the next line. So we're going to have 3 lines of text, 0, 1, and 2. And there we go. As predicted, all of our numbers printed out on one line, but our names each appeared on their own line. Index 0 is Gilligan, index 1 is Skipper, index 2 is Ginger. There's another way to allocate an array as well, where you pre-fill it with data. Here we've allocated our array by creating the array, allocating it there, and then sticking in pieces of data one by one. Well, we can fill it with data right when we create it if we use what's known as an initialization list or an initializer. So, int phone, like a phone number, subscript in subscript equals curly brace. If you like classic rock, you're going to know this number 8, 6, 7, 5, 3, 0, 9. Now we don't know how long this array is. We could count them and fill it in, right? We might say that all phone numbers are 7 digits long. Or we could use this strategy of calculating the number of items. Let's do that. Int len underscore phone equals size of parentheses phone in parentheses divided by size of parentheses int. And again, to be better programmers, we should make it the size of the first element rather than just size of int, because what if later on we change these to longs or doubles or something? Then our length is no longer accurate. This is a perfectly valid way of doing, though. It's just not the most defensive. And now we can print our phone number out. Same idea, same kind of loop. We're going to print it with a slightly different loop, though. This is known as a for each loop. The textbook may call it something slightly different, and you've seen this syntax if you're a Python programmer, or you've used Java array lists. For int value colon phone, for every item, maybe I'll just call it item, I don't know. For int item colon phone, for every number we find, we're going to write it out. Cout arrow arrow item, arrow arrow endl. This way of accessing an array is known as using array indexing. That's an index-based for loop. This is a value-based for loop, stepping through the array one by one. Now there's some magic involved here that I don't understand, which is if we can't get the length of the array by asking the array, how can the for statement do it? Notice that we didn't use this value. If we commented that value out, it's still going to work. So it's weird to me in this language that that works, but it does. They wanted to keep neck and neck with Java, so they added support for that. All right, and there's our phone number, 8675309. We're going to print the array out the same way using index-based printing, an index-based loop, just so that we can eyeball the differences and kind of decide which one we like better. For, I really wish I'd put value. I'm going to replace the words item with value. You don't have to. So, for int I is equal to 0, same deal. I is less than len underscore phone, semicolon, I plus plus. It looks like I have a syntax error. It looks like my int I wound up missing an I.
What does len mean again?
Length.
Oh.
Oh, yeah, sorry. We could make it a better variable name. Length underscore phone, like that. If I make that change, it's going to break somebody. I'm going to undo that. So cout arrow arrow phone subscript I in subscript arrow arrow endl. Now a lot of folks wouldn't calculate the size of the length of the array. They just put this expression right here. I'm going to undo it so you don't have to do it. Don't do it. They put that right there. That makes that for loop look hairy, right? But we didn't have to create a variable to hold that value. I don't particularly like that one because it's doing math inside the for loop, and if you're repeating that loop 7,000 times, it performs that operation 7,000 times, which is a lot slower than just looking up a variable. I'm going to undo that. For clarity, though, I'm going to cut this int len phone and paste it above the loop that uses it. All right, I want you to eyeball the two loops. Which one do you like better? That one or that one? I like the first one better. The syntax is much cleaner. Unless I need to know the index number, I would do it the first way. The only reason you might want to not do it the first way is if A, you need to know the index number for some reason. And do you remember up here when we were printing out the names of Skipper and whatever, we put the index numbers next to it, so we could not have done it that way? Or if you're going to change the array as you go through it. Because in order to change an element of the array, you have to have its index number. So that for each syntax is great. I'm going to add a comment to that effect. For each syntax is great and simple, but is effectively read-only access to the array and doesn't let us have access to the index numbers. It doesn't give us index numbers, right? Because there's no I involved there. There's no counter. Yeah, you could fake it. You could create an int I is equal to 0 above it and then increment that each time you're going through it. But if you're going to do that, you may as well use a for loop. This is the kind of thing I'd really, really like you to memorize. And we'll be doing it more and more, so it's not like this is the only chance you'll get to do it. But memorize these two syntaxes. Memorize the index-based loop and memorize the for each loop. Now the C# language is cool because you actually have the word each in it. Like, don't type this because it doesn't work in this language. But it's for each int value in phone. I like that, right? Tells you exactly what it's doing. But this one doesn't have that. I'm going to make the same problem and hope that it manifests here. What if you typoed that? What is wrong with that? We only have 3 spaces for numbers here, or for names, excuse me. Yeah, we only have 3 strings, and so we're putting in one in the first place, one in the second place, and one in the fourth place. That is that error that I was telling you about. You're writing past the end of the array. And it doesn't tell you that you're writing past the end of the array. It's subtle. You don't know that there's a problem. And then you run it, and boom, I get an exception. And it doesn't show it in the right place. It shows it in this place. Now hers was showing it in a different place still. You know, the behavior is kind of undefined. You can't predict how it's going to work. And so notice that now that I hover my mouse over num items, it says that the number of items is 6. But when it printed it out, number of items was set to 4. So it got corrupted. Writing past the end of the array corrupted the value of num items. Brilliant example of it. And boy, it was hard to spot, right? We could have looked at that code all day and not noticed that there was a 3 there where there was supposed to be a 2. So the 5 is known as the length declarator, although the book called it the size declarator. The size of the array is the total number of bytes times the number of bytes of each element. Doubles are 8 bytes long, and so if you have an array of 10 doubles, it's 80 bytes long. because 10 times 8 is 80. A very common thing to do is to make your size declarator a variable and then use it. Notice that we made it a constant. This language, unlike a great many others, requires that variable to be a constant if you're going to do it that way. If I went down here all the way above my pause, and I did this, int size equals 4, 3, whatever, I'm probably going to wind up commenting these out. You don't have to type them. Int mynums subscript size, like that. It underlines it because size is not a constant. The compiler demands to know and to be assured that the value of that it's supposed to allocate for that cannot change. So we would have to declare that as a constant to get it to work. Now, I can't even think of what to do with this mynums business that we haven't already done. We could copy the elements of the old array into the new one. And by the way, that size of array divided by size of element doesn't work if you're passing the array to a function, which is perfectly illegal. You're supposed to be able to pass an array into a function. We'll give an example of that in a little bit. If you did type this, add the comment, must be a constant, or else this line won't compile. If you didn't type it because I didn't tell you to, or because I told you not to, then that's fine. Accessing array elements. You access them by their subscript, also known as their index. That's element 0, that's element 1, element 2, element 3, that's subscript 4. The way you state it like a computer scientist is you say is that the index, the subscript, can be from the values of 0 to n minus 1, where n is the length of the array.
He said it was
Do we have a syntax error we need to
Yeah.
fix? All right.
just noticed it.
So any element in the array can be accessed just like it was a regular variable. What do I mean by that? Remember we had that nums array up here? Or some of y'all were calling it num. Well, you could do this, right? Int x equals 3, int y is equal to 4, int z is equal to x plus y, right? We're allowed to do that. That's perfectly good. You could also do this. Nums subscript 3 is equal to nums subscript 1 plus nums subscript 2. That's totally legal, right? Because that element is an int, and we could use it in any part of an equation, any part of a formula that you can use an int. Now, we couldn't leave the subscript off. That's an error, right? It doesn't know what that means. So we have changed the third element. And if we printed out the array again, we would see that the third element has changed. Arrays must be accessed via the individual elements. In Python, this kind of worked. You could print parentheses list name. This doesn't work. That's why we had those for loops to print it out. Let's create an array with some numbers and then write a loop that will add up those numbers to create a total. Good old sales. We're going to calculate some sales. Double sales. How many sales are we going to have? Well, let's declare a constant to hold that. There's 7 days in a week, so let's do const int days equals 7. And then the length of our sales array, the size declarator, is going to be days. Let's put some sales in there. Days subscript 0 is equal to 100. Days subscript 1 excuse me, what should that be?
Sales.
Yeah, that should be sales subscript 0 is equal to 100. Sales subscript 1 is equal to 200. And I'm just going to do some copying and pasting because I want to fill all 7 spots, 0 through 6, with data. So don't type my numbers, just type in whatever you feel. All right, so I've got some data in it. I can write a loop that'll iterate through it. We could print them all out. While we're thinking about it, let's create an array of names of days, like Monday, Tuesday, Wednesday, Thursday, and Friday and Saturday. This will be called a parallel array because it's the same length as the sales array, and the elements are united. They're linked together thematically by their index number. So weekdays, wait, got to declare the type, sorry. String weekdays, open subscript, close subscript, equals, open curly brace, let's type in some day names. Quote, MON, end quote, comma, for Monday. Quote, TUE, end quote, for Tuesday. You can see where this is going. Quote, WED, end quote, comma. Quote, THU, end quote, for Thursday. Only got 2 more to go, Friday and Saturday. No, I have Sunday as well. Quote, fry, end quote, comma, quote, sat, end quote, comma, quote, SUN. Close curly brace, semicolon. And a for loop to print them out. Although we don't know how many weekdays there are, we could have gone ahead and put in days here. That is correct syntax. I just tacked that on there, and it kind of guarantees that this array is 7 elements long. So even if we had left off a day or 2, it would be 7 elements long. Now that kind of leaves open the question of what happens if this length doesn't match that length. Right, what if we had only 5 day names, but we had set days equal to 7? Or what happens if we have more items in here than that supports? Well, I wonder if it would count that as a syntax error. This is just me playing. There. Now we have 2 more items than the days array could support. And it's complaining about it. Good, it's supposed to. But it is legal to have fewer elements in your initializer list than in your size declarator. All right, I'm going to compile it. Even though it's not printing anything new, I just want to make sure that it builds. No syntax errors, I hope. All right, and it worked. So let's print out this data. Let's print out our sales array. But we're going to use our weekdays array to give ourselves some labels so that we know Monday we sold $1,000 and Tuesday we sold 2001 and so on. So for same business, parentheses, int, I equals 0, I less than. What variable should I put here if I'm not going to use the size of trick? Well, how many days do we have? I could put 7, but we have a variable set to 7 up here, so I'm going to just put that there. So I less than days, I plus plus. Why not just put 7? Well, we may change this application so it's 31 days a month or something like that. We might move to the planet Klingon where every week has 10 days. I just made that up. All right, so let's print out, just for our debugging purposes, let's print out the index number. We might take that out because it's going to look ugly. No user wants to see day 0 and day 1 and day 2. They won't understand why there's a day 0. So cout arrow arrow I, arrow arrow quote space quote.
Put it backwards.
Oh, backwards, thank you. Less than quote space quote.
Could you scroll to the beginning of the right? Sorry.
How far up?
There. That's good.
All right.
All right. Scroll down. Thank you.
So, and then arrow arrow followed by the day name, which is weekdays subscript I, followed by another space. You know what, and we could be putting tabs here rather than just spaces. So I'm going to replace that space with a /t, and that space with a /t. And then since I'm running out of room and you're not, I'm going to go to the next line and do arrow arrow sales subscript I in subscript. Maybe we'd want to put a $sign in front of it. I didn't. Arrow arrow NDL. And here we go, right? Monday we sold $1,000. Tuesday we sold $2,000. Wednesday we sold. I really would like to see that $sign there. And it'd be kind of nice to, you know, print out what we were seeing, you know, have some kind of headers. We'll worry about that later, but I do want to see a $sign here. So before the sales, I'm going to print out a $sign, end quote, followed by that. So I just inserted that there. And we could use some I/O manipulators to force ourselves to print, you know, a decimal point followed by 2 digits, which would be, you know, the number of cents, something like that. Okay, I'm liking that. Are we digging these numbers? Not really. I'm not. We could take that part out of our loop if we wanted to. The reason I put them there is to just reiterate the name, the fact that this is our weekday, and that this is our sales, and that's our index number. Let's print that out. Let's go ahead and add ourselves some headers. Above our for loop, do this. Cout arrow arrow quote weekday end quote, or /t for tab instead of the end quote. Wait. Our first number isn't the weekday, it's the index. So I'm deleting all that. Cout less than index /t weekday /t sales /t. No, wait, we don't need a /t there. We need a \n. Go to the next line. I hope that looks good. Never can tell with tabs. There we go. I'll bring the code back in just a second. What am I wanting you to see? Parallel arrays. We had an array called weekdays and an array called sales. Monday sales were 1,000. How do we know that? They both share the index 0. Tuesday sales were 2001. How do we know that? They both shared the index value 1. And so on all the way up to Sunday, which is index 6. So weekday 6 is Sunday. Sales 6 is 1,200. So let's add a comment to our code as to what a parallel array is. Parallel arrays equals 2 or more arrays of the same length where the elements are linked by their subscripts. About time for us to stop.
Yeah, we only have 1 minute left.
Yep, we have 1 minute left. Alrighty. I'll bring the code back. I'm going to be staying after. But not all y'all are. I need to set a timer so we stop 5 minutes before. So I can tell you about your homework assignment. But I will anyways.
No.
You went, I don't want homework.
It's too late. It's too late. We got less than a minute. You got 0.35 seconds.
Alright, here's our homework. Create an array of 6 ints called nums. Write code that places the first 6 digits of pi into the nums array. Don't use an initializer list. Yeah, what are the first 6 digits of pi? Well, what do you know? I give them to you right there. And then write a loop that'll print the nums array with a loop. And then down here, create an array called movies. Do use an initialization list. Use the equal and the curly braces to set it to like 4 or 5 movies that you like. Or if you hate movies, books. Or, you know, great artists, Van Gogh versus, you know, Monet or whatever you like. And then print the movies with a for each loop. So if you follow the examples in the notes, this may be a really short homework assignment. And if you get stuck on it, if it's not a really short homework assignment, then go ahead and text me about it, or let's stay after. No, we won't be able to stay after on Tuesday. Thursday's the only day I can stay after. All right, Dropbox. Why did I close the window? Pardon me?
Do you not have a Dropbox for T lecture?
Gonna be. Wait, did we not? Did we not upload anything for T? Thought we did. It's right there.
Oh, there's 2 pages.
No, there's no 2 T's. I hope not.
Oh.
Anyways, let me make the use so that people can bail. All right. So we're talking about arrays. An array is a sequence of values. Easiest way to think of it. It's a series of values. So with one variable name, we can access a whole bunch of data rather than just one piece, rather than just age equals 7. You could have an array of ages and you could store 10,000 ages in that array. You think I'm kidding, but let's see how large of an array we can actually allocate. We're not going to actually mess with doing this for too long, but I'm going to try creating an array with 100,000 elements in it and see if it complains about it. We are on project LMLPQRSTUV. It's a new project, lecture V. Grab the boilerplate. File new. All right. So the syntax for declaring an array is data type, name, array name, followed by the subscripts, and X, length, where that is the length of the array. Let's make an array of ints called nums. Int nums, and it's going to be 100,000 items long. And we want to initialize them all to the value of 0. We haven't played with initializer lists much yet, but if we do this, what that says is set the first value equal to 0. And then, oh, since we didn't give any values for the other ones, they'll all also be set to 0. Now, that doesn't mean that if we set this to 1, it'll initialize every element in the array to a 1. Instead, it means set the first element to 1, and then the rest of them will all be 0. See, that works. If this number here is larger than the number of elements in the initializer, then the ones that are not specified all get filled in with zeros. So this would mean that the first element gets assigned to 1, and then the rest are all zeros. Whatever. Let's write a loop that'll add up all those values. Just see how long it takes us. So double total equals 0. And we could use an index-based loop, or we could use a value-based, a for each loop. Let's use an index-based loop. For int I equals 0, subscript I less than. Now see, here's where I should be asking the array for how big it is. And I didn't. So I'm going to come back up here and I'm going to declare a constant to hold that 10,000. It's just going to be called array size or nums size. So const space int space nums underscore length equals 100,000, 1 followed by 5 zeros. And then instead of using 100,000 there, I'm going to use my variable name, nums underscore length. And I will paste that there. And lastly, I will also paste that there. Okay. So for int I is equal to 0, I less than nums underscore length, semicolon, I plus plus, I short for index, total plus equals nums subscript I. And since our first element is equal to the value of 1 and all the rest of them, all 999,000, the rest of them are zeros, it's only going to equal 1. But I'm just curious about how long it's going to take for us to display this. Total equals, comma, end quote, for total equals, end quote, arrow, arrow, total, arrow, arrow, ENDL. We're going to find that it's pretty dang fast. Computers are fast nowadays. The time it takes to compile it is infinitely longer than the time. Okay, yeah, see, it added all 100,000 numbers in the blink of an eye. What if we make it 1,000,000? Will it support 1,000,000? I just added in an extra 0 there. All right, Stack Overflow. We used up too much RAM. Since each int is 4 bytes, the program was trying to allocate with one call 4 megabytes of information. Now, there are some things we could do that would actually enable that, but I was just kind of curious as to how large we could go before it would complain. So that didn't work, so I'm going to click the little red stop up here.
When you say use too much RAM, is that based on how much the program is allowed to use, or based on how much RAM you have in your computer?
It's not based on how much RAM is in your computer. It's based on, by default, how much memory is being allocated to that application. And there's a way to modify the settings of your compilation to give it more stack size, but I can't explain that in 2 or 3 clicks, so I'm not gonna. But we would have to go out and we'd have to find the setting where we specified the stack size for the compiler and then told it, nah, we're going to be dealing with large data sets. We need to be able to access more than 4 million. So I'm going to change that back to 100,000. What if we wanted to fill that full of random numbers? I don't know. That almost sounds like a homework assignment. Almost be too easy to do right now. Let's remind ourselves, somebody remind me of the name of the library in which the random number function is in. Is it STD LIB, standard library? C++. Yeah. So yeah. But I thought there was a better way of doing that. So it's part of C standard library. All right. So yeah, we're going to fill our array up with random digits. So # include angle CSTD close angle. Now they're not going to really be random numbers because we're not going to take the time to set the seed value. So the seed's always going to start at 0. So every time we printed these out, they would be the same random values, which isn't very random, right? But the same sequence, but that's okay. So we're going to need an array that will go through and let's just change that to 0. It's bugging me to see that. We're going to need a loop that's going to go through and set all the values in the array equal to a random value. So for parentheses, int I equals 0, I less than nums underscore length, semicolon, I plus plus. And by the way, that was a really good question about the memory. Nowadays, modern operating systems use what's known as virtual RAM so that their amount of physical memory in your computer does not really dictate its limits because it's spooling memory out to disk and then reading memory back in from disk as it needs to, so that it can pretend it has a huge amount of RAM available to it, even if you've only got like 2 or 4 gigabytes installed on it. That's what that page file .sys file is. If you've ever noticed that you have a huge file sitting in the root of your hard drive. Oh, it's not going to show it to me. It's a hidden file probably. Anyways, it'll be set to the amount of RAM that your computer thinks that it needs to emulate, 8 gigabytes or something like that, a page file. And actually, no, I just lied to you. Forget everything I said about that. The page file is what's written to disk when your computer goes to sleep, I think. I'm going to stop talking like I know what I'm talking about. All right, so here we go. For int I is equal to 0, I is less than nums length, I plus plus, swap file. Swap file.sys is the one that I'm thinking of. Nums underscore I equals REND, parentheses, in parentheses. And let's say that we want numbers between 1 and 1,000. So what we're going to have to do is to do mod 1,000 like that, but then add 1 to our result. If you wanted it to be between 1 and 6, you just change the mod to 6. Now our total is going to be significantly different, right? We're going to actually have data in there. But still, it didn't take any time to add that up. 40 million, 49 million is what the total consisted of. Why don't we print out the first few digits in our array just to see what it looks like?
I'm getting a syntax error for some reason. It's saying my I is undefined. I don't know why.
Do you have int in front of it there?
Yeah, I got that.
Do you have a semicolon right here?
I do.
Yeah, take that semicolon out. If you put a semicolon there, remove it. Those are like if statements. If you put a semicolon after the end of the for syntax, it breaks it. That fix it? All right. So let's print out the first, I don't know, 40 elements of that array. And the first 10 will do, right? So for parentheses, let's add a comment as to what we're doing now. Print the first 10 elements of the array. Yes, thank you for shutting that. For int I equals 0, I is less than 10 because we just want to count up to 10. For int I equals 0, semicolon, I less than 10, not greater than, I plus plus, cout, arrow, arrow, nums, subscript I, arrow, arrow, quote, space, quote, in semicolon. Now I'm trying to print them out all on one line, and so that's why I did not use ENDL. But once the for loop is done, we want to go to the next line. So after that closed curly brace, cout error error NDL. And just want to see what our random data looks like. And there they are. When you run it, you'll probably see the same thing. I bet your first random number is 42. Does that seem to be the case? Yeah. Okay. I'm going to go back and add a few more comments, like what are we doing here? Fill the array with random numbers. 0 to 1,000. And then this code down here calculated the total. Calculate the sum total of every element in the array. But sometimes you want to search an array, meaning you're looking for a specific value in the array for whatever purpose. Maybe we want to find if anything is equal to the number 13 because we don't like that unlucky 13 and we want to change it to a 12. This is just silly. But let's go ahead and write something that'll do a linear search. So way down here, what is a linear search? It's where we start with element 0. We say, hey, are you 13? Nope. Go to the next one. Hey, are you 13? Nope. We go to the next one. Hey, are you 13? Yeah, we found it. Okay, and then we stop. That's called a linear search. Now, if your data is sorted, you can do a more efficient search where you guess halfway in the middle, like between, if you have a list that's 100 elements long, you look at the 50th element. And is that not right? Okay, well, you jump back half, just like that guessing game. I'm thinking of a number between 1 and 100. 50. Nope, that's not right. 75. Nope, go lower. And then halfway between 50 and 75, you can keep zeroing in on it. It's called a binary search because you're breaking it into 2 each time. We're not going to do a binary search because this data is not sorted. The only way you can do a binary search is if it is sorted. But anyways, let's write a linear search. Our target value that we're looking for, we want to find a 13 in it. I just picked that completely random. And so now we're going to have an index value which indicates whether the value is found or not. I'm going to just call it found at. Int found at. And I'm setting it equal to -1. That's going to be our key, our indicator, our sentinel that it was not found. So if after we go through the loop, if found at still equals -1, then we never found it. So for, and yet again, int I equals 0, I less than the number of arrays. I've forgotten the name of that constant. Num underscore length, nums underscore length, nums underscore length, semicolon I plus plus. We're going to check to see if that particular value at that specific index is equal to our target. If nums subscript I in subscript equals target, we found it. Curly brace, cout found, end quote, arrow arrow, in target, arrow arrow, quote space, at index, end quote, arrow arrow, I, arrow arrow, ENDL. And so now let's put that found at variable, found at, and set it equal to I so that we know we did find it. Found at equals I. We're just taking note of which position in it. Like we were searching in an apartment complex for For a convicted felon on the run, we open every door. We finally find him in apartment number 234. We're happy to know about it, so we keep track of it. So after our loop is done, we can check to see whether found that still equals -1. And if it does, we never found it. So if found that equals -1, close parentheses, curly brace, cout, target, space, end quote, arrow, arrow, target, arrow, arrow, quote, not found, \n. Else, cout, arrow, arrow, target, space, end quote, arrow, arrow, target, arrow, arrow, quote, found at index, space, end quote, arrow, arrow, found that, if I could type, found at, arrow, arrow, ENDL. All right. Now it actually found a whole bunch of 13s. I guess that's not surprising. We have 100,000 generated numbers, all of them between 1 and 1,000, so 13 occurred a lot in it. What if we only wanted to find the first one? What if we wanted to stop right here at position 1037 and not keep going for efficiency's sake? I can think of 2 possible changes we can make to our for loop, but I'm wondering if anybody else can come up with one. Here's our linear search loop right here that is searching from beginning to end. When we find the array, when we find the target, we set the found at equal to the index. What else could we do now to stop searching at that particular point?
Could you scroll down to the else?
I sure can. Exactly, we'll break. We're going to put a break statement here so that we don't need to keep searching. So after found that equals I, we're going to break to exit the loop. Don't need to keep going. So break, semicolon. Now should only find one occurrence. 13 was found at index 1037. Guess I don't need the words hello world anymore in my program. Anybody got any syntax errors that you would like? The reasonable thing to do would be to make this a function, right? There's no real reason every single time you want to search for a specific value to rewrite that loop.
I'm doing
All right. So we should probably turn this into a function, but rather than copy and paste it, I'm just going to rewrite it. Pardon me, does anybody else have syntax errors? Somebody said something. I swear I heard somebody say something. Okay, so we're going to write a function that does a linear search. I'm just going to call it linear search, and it's going to return an integer. So here's what our function looks like. int space linear, well, if I could spell linear, it would help. LINEAR underscore search. We need the array name, so I'm just going to call it AR for array. In AR subscript, in subscript. We also have to know the number of items to search. So int LENGTH, comma, and then the target we're looking for. Int target. Now it's going to be the same kind of business. We just declare a variable called foundat, and at the bottom of the code we're going to do return foundat. So int foundat equals -1. The bottom line of our function had better be return foundat, but between those two lines is where we're going to put our loop. For same business, for parentheses int I equals 0, I is less than LENGTH, semicolon I plus plus, curly brace, if parentheses nums subscript I equals target, close parentheses, open curly brace, foundat equals I. And we could either do a break or we could just do a return right here. But just to make our logic look exactly like the other one did, I'm going to make it a break. And I'm sorry, my array name was called AR, and I suddenly started calling it nums again. So I replaced nums there where they are. And let's write a description of what this function does. Searches array AR for the target value, returns the index or -1 if not found. We actually do in this language. We've seen ways of calculating the length of the array. Let's play with that a little bit. Well, let's make sure this compiles. All right. We have seen that we could get the length of an array by doing something like this. Int size equals size of parentheses nums in parentheses divided by size of parentheses nums subscript 0 in subscript. Right. We've seen that that works. We could print out the size of the array right there. Print out quote array length equals end quote arrow arrow size arrow arrow NDL. But this only works if you're in the same context in which the array was allocated. And this is a quirk of this language, and it's not true of C++ or Java or Python or umpteen other languages. Okay, so the array length is equal to 100,000, just like we said. But if we declare a function that's supposed to like calculate the size of the array and return it or whatever, int get size parentheses, and we're going to take an array, int nums square brace close square brace. Now this code's not going to work. Let's pretend it's going to though. Int size equals size of subscript nums in subscript divided by size of, parentheses, nums, subscript 0 in subscript.
Do you want us to type in that? Or is this
Well, this is not going to work, so I don't care if you type this or not. I'm going to wind up commenting it out or something like that to get rid of it. And then return size. And when I try to run it, well, I didn't call it. Let's try calling it. Size equals get size, parentheses, nums. And let's print it out. So I guess just copy and paste that line here. I was hoping it would actually generate an exception, but what we see here is that it says the array length is 1. You cannot use the size of trick to calculate the number of items in the array unless you're in the same block of code where the array was allocated. If you pass it in as a parameter to a function, then you can no longer do that. I don't know what it's doing to calculate that. I mean, we can print out size of nums, you know, we can print out the individual pieces, but we just have to know that we can't do that. So that's why we had to pass the length in. Because in this particular language, you cannot ask the array for how long it is. Now we saw in Thursday's lecture that there's a for loop where you don't have to know the length. Beautiful for loop called a for each loop. However, that doesn't work inside of a function either if you're out of the context in which it is declared. No, I say that. I could be totally wrong. Let's find out. Let's find out. We're going to write something that prints out all the elements of an array using a for each loop. And we're just going to see if it works. Maybe this is going to be an array of strings, though. I'm tired of our numbers. So, public, wait, not public, void, because it doesn't need to return anything. Print underscore array, parentheses, string, AR, or maybe the whole word. We're not being charged by the penny, so array, string, array, subscript, in subscript, close parentheses. And now here's the syntax that we should be able to use to print the array. For, parentheses, string v or value, colon, array. And it's already giving me grief. The compiler's not even letting me try it. It says this range-based for loop requires a suitable begin function and none was found. Well, that's a lot less and more information than I want. Basically, I can't do it. I cannot use a for each loop or a range-based loop is what they're calling it here. I guess I better make comment of it. A range-based for loop is what I was calling a for each loop, which is what it's called in C#, C++, excuse me, in Java for a value-based for loop in Python. So calling anyways, that doesn't work. We can't do it. We can't do it like that. So instead, if we were going to print the array, we would have to pass in the number of elements in the array. There are some ways we can get around that, though, by using something known as a reference. Now, Python and Java are known as pass by copy or pass by value, meaning that you're not getting the actual variable itself. Whenever you pass it into a function, you get a copy of it. But you could say, no, I really want you to be able to have access to the original memory that I'm indicating and not modify it, not change it. And I think I better lecture a little bit more about arrays before, but I really do want to mention references and pointers as well. So I'm not going to work that in. I guess we just need to do another example, maybe of, why don't we look at this line? That's what we're going to do. Have I broken anybody's code? Is your code no longer working because I started adding things? I broke Rochelle's code, didn't I? All right, let's take a look. So using a loop to step through an array. Here's an example. Array size is 5. We declare an array of size 5. For int is I count is equals 0, count is less than array size, count plus plus. Numbers subscript count is equal to 99. This will initialize every value in the array. It will set every value, assign every value in the array, every element to the value 99. So default initialization. In some languages, once you create an array, they're all set to 0. In this language, they're not. What do I mean by that? Let's make a new array down here, right before our system pause. Int more nums. And we want 10 of them. Now let's print them out. But let's use a for each loop, or a range-based loop. For int value colon more nums. In other words, for every value that's in the for nums array, curly brace, cout value, followed by a space, arrow, arrow, space, semicolon, and then after the close brace, cout, arrow, arrow, endl. And there we go. Well, boy howdy, that doesn't really look like useful data, and it's not. It's certainly not all zeros, and you might wish that when you created an array, it would all be initialized to 0, but C++ does not take the time to do that. Well, that sure is suspicious because it's the same value every time. Yes, because the Microsoft version of C++, if you're compiling for debug mode, fills every uninitialized element in the array with the same value to make it real easy to spot. However, the behavior of it differs where the array is allocated. If I allocated that array outside of any function, if I made it a global variable, if I cut this out and pasted it above main, now I'm not going to ask you to do this because I'll probably undo it immediately, but if I went up here and I cut that and I pasted it and put it above main so it's now a global variable and I run it, when I run it, they were all initialized to 0. So just because we moved it to somewhere, just because we made it a global variable changes behavior. All right, I didn't invent the language. I can't complain too much about that. But if you do want them to all be initialized to 0, we've seen the syntax for it. Do it like this. Just say equals curly brace 0. And what that does is it sets the first value to 0, and then all subsequent values, instead of being initialized to that weird 8 billion value that we were seeing, are also all set to 0. And again, if we change that to a 1, it wouldn't set them to 10 ones in a row. It's just that the first one would be a 1, and then the rest of them would be a 0. And as a matter of fact, we could prove that to ourselves. Inside your initialization list, type like 3 numbers in. 34, 55, 66, and then run it. And notice what the last 7 values in the array are as compared to the first 3. 34, 55, 66, all followed by 0. So the initializer list fills in up to the point where we stop giving it data. If we don't have enough data for it, then it just fills it all the way in with zeros. And so if we stick a comma, a 0 here, the first element becomes 0, and then the rest of them are all defaulted to 0. If we set it to a 1, the first element becomes a 1, and then the rest of them are all set to 0. So that's a nice, quickie little syntax to initialize the array to zeros. Why would you want to do that? Well, it's a real drag if you're trying to like add totals or whatever, and you have pieces of data that you're trying to add, and you're getting 8 billion added to it each time because we're using uninitialized data. Well, why might that occur? You can have what's known as a partially filled array. A partially filled array is when you've started adding data to the array, but you're not done adding data to the array yet, so it's not full. So like if we had a weekly sales array that was 7 elements long because there's 7 days in a week, and we asked them for the sales of Monday and for Tuesday and for Wednesday, yeah, the first 3 elements are going to have data, but Thursday, Friday, Saturday, and Sunday won't. So let's do that. Let's mention the idea of a partially filled array. An array in which not every element has data assigned yet. So let's do int sales, 7 days worth of sales, equals curly brace 0, initialize them to 0. Now let's make an array of day names, string days, subscript 7, or we could even leave the 7 off because we know how many days we're going to add to it, but equals curly brace, quote, MON, end quote, comma, quote, TUE, end quote, comma, WED for Wednesday, end quote, comma, THU, end quote, comma, FRI. I'm tired of typing, so I'm going to change this to a 5-day sales week. There we go. And after the close curly brace, a semicolon. So let's add, pardon me?
Change that string days to 5.
That should be 5 as well. You're absolutely correct. And what we really should have done is declare that 5 as a constant. If we do not define this, then it defaults to being the length of the number of elements in there anyways. So I think I'm going to just leave that off. I'm conflicted. I'll make it 5. Alrighty. So we're going to ask the user to enter the sales for that day. So we need a loop. Loop that's going to count from 0 to 4. So for parentheses int I equals 0, I less than. Let's ask the array how big it is. Say size of parentheses sales in parentheses divided by size of sales subscript 0 in subscript. So in subscript, 2 end close parentheses, and then a curly brace. So let's ask them, cout, error quote, sales for, end quote, error, days subscript I, in subscript, error quote, space, greater than, just to let them know that they're supposed to type there, end quote, semicolon. And now let's let them type it in. CIN, error, sales, subscript I. I seem to have an error here. I see a closing. Oh, I forgot to put I++ at the end of my for loop here. My for loop syntax is wrong. Right there, between the 2 closed parentheses, there needs to be a semicolon I++. So that's what I left off right there. Now just to kind of prove the point that it's a partially filled array, I'm going to stick some debug code in here that's going to print out the contents of the array each time. We should make it a function. It's not gonna. So let's use a range-based loop, a for each loop, for parentheses, int value, colon, sales, into parentheses, cout, error, value, semicolon, and then the next line, cout, error, EMDL. Let's just start debug printing of the array elements. About the fastest possible way, or shortest to write. All right, so sales for Monday, $100. Sales for Tuesday, 200. Sales for Wednesday, 300. Okay, now this is dumb because look what I did. I forgot to put spaces in my output here. So I'm going to go back to my little for print statement here. And where I say see out arrow, arrow value, semicolon, I'm going to insert before that semicolon another less than, quote, space, quote. So I just modified that. This is now our printing loop. We really should make that a function though. So we can print out the array anytime we wanted to. Okay, so right now, sales for Mondays, 100. All right, and look, we have 100, but the rest of it's filled with zeros. 200. Now we still have 3 zeros left that haven't been filled in. 0. Okay, well, that may be legit. And then 200. All right, so Thursday we had 200, and then Friday, 999. Okay, so if we were looking at this array at any point before we had it completely filled, we wouldn't know whether a 0 meant data that hadn't been set or whether it was really a day of no sales. So if we were going to calculate the average, we wouldn't be able to do that. We wouldn't know how many days, right? What if I tried to calculate the average after entering only 2 days worth? Is our average sales 100 plus 2, is that 300 divided by 5? No, I only worked 2 days. Why am I being average for 5 days if I only have 2 pieces of data? So that's what's known as a partially filled array. And to work with a partially filled array, you have to keep track of how many numbers, how many pieces of information you have saved in it. So each time we go through here, we might be adding 1 to it in order to indicate that that's how many values we have in our array. So the problem with a partially filled array, you don't know which items have good data. Just because it's 0 doesn't mean it's bad data. 0 is a valid value, right? So, and yeah, you could try to do some kind of trick where you initialize it all equal to -999, and then when you're processing it, you check. What you got to do, though, is what you really have to do is to keep track of how many pieces of data you have in there that are valid. Now, in this particular case, since we're going from beginning to end, we know how many pieces of data are going to be in it by the time we're done. It's going to be 5. But what if it was one of those things where it says, you know, enter test score or -1 to exit? Well, if they enter -1 before they've entered all 100 test scores, then again, we don't know where the good data begins, where the good data ends, and the null entries begin. I think I want to let that percolate in the brain while I go to the slide. Any typos anybody wants me to look at?
Yeah.
I'm gonna have to watch this lecture though.
Uh-huh.
All right. So as mentioned, if an array is a global variable, all the elements get initialized to 0. If the data is local, then they are not all initialized to 0. And we could prove that to ourselves by changing it not to compile in debug mode, but to compile in release mode by doing that little pull down, rebuilding the application, running it without debugging. And maybe they are initialized with zeros. It sure does look like it, but you can't guarantee it. Oh, that's because I have that equals curly brace 0 in there. I'm going to take that out temporarily. And there they are. If we were trusting those to be zeros, and instead there were that series of numbers, that's just whatever's in the memory contents at that particular time, right? When we said we want an array of 10 spots, we said, okay, you have enough memory now to hold 10 numbers, but it didn't do anything with those numbers, what was already in the memory. It didn't wipe them out or anything. That's why we have that cute syntax for setting everything equal to 0. So there is no bounds checking in C++, meaning that if you try to read an element with a negative index or an element with an index equal to or greater than the length of the array, it's not going to stop you from doing that. Which can create real problems. Let's create just a simple little itty bitty array of 5 pieces of data, and then we are going to try to access more than 5 pieces of data in it. So maybe they're going to be doubles, I don't know. I better set it back to debug mode to make sure that I'm seeing exactly what you see. So double DAR for double array, subscript, in subscript, subscript in subscript, square brace in square brace, equals, curly brace. Just type in some numbers. 1, 2, 3, 4, 5, 6, 7, 8, 9, like that. We better get the size of that. But I'm going to pretend that I'm a dummy and I don't know how many elements are in it. I'm going to print out 100 elements starting with the first element. So for parentheses int I equals 0, I is less than 100, I plus plus, cout arrow arrow dar subscript I, arrow arrow quote space quote, semicolon, and then print out our carriage return at the end, cout arrow arrow PNDL. Okay. There is some kind of data, but there's not. There just happens to be some memory contents past that point, but it's not data that we should be accessing. It kind of has a look of that kind of default data that we saw the debugger throwing into an uninitialized array, because I see the same values repeated over and over, but not every single time. In fact, I'm not sure that that's true. I'm not sure that I'm seeing repeated numbers or my eyes are just being, eyes are crossing.
It looks like it needs an exorcist. I don't know what's going on with that.
Yeah, so what's happening is it's reading past the end of the array, which you can't do in Python. Python will throw an exception if you try to ask something past the end of the array. You can't do it in Java. Java will do the same thing. Java will complain most vociferously if you try to do that. So when we have an array, I know we have a picture of one somewhere, right?
Talking about like a grid array kind of thing? Or?
I thought we had a picture showing, well, I guess this would do. Here we have an array of 3 elements. So we said, yo, operating system, I need some memory and it needs to be long enough to hold three doubles. So it does that, it gets us to it. But then we say, okay, now I want to know what the value of the 4th element is. Whatever's in RAM there, it goes ahead and tells you. It's just not data that you should be accessing. Same if we started using negative indexes. We could go back there and we could read data that was out of bounds of our arrays. We're reading parts of the memory that we should not read. And as bad as that is, it's far worse if you're changing those values. And I think I demonstrated that last time, to where if we start changing the values outside of the edge of the array, then the debugger will probably catch it and stop the program from running. But that's because we're running in debug mode. If we were running in release mode, then the debugger is not trying to stop us from doing that at all. So it does not do bounds checking, meaning you need to make sure that you don't read past the end of the array, which is why we do things like that size of business to get the length of the array out. Because we really only want to print out, right, the number of elements that we really have. So int dar underscore size equals size of dar in parentheses divided by size of dar subscript 0. And you see why we're doing this second one, right? This is just to get the size of that element. Now we know what kind of element it is. We could replace that dar subscript 0 with the word double, and it would work just as good. But then later on, if we change this to a different data type, like long or whatever, we'd have to change this one as well. Whereas if we leave it the way it was, just tell me the size of the first element in the array. Then it doesn't matter what type it is, it's still good code. So DAR subscript 0. All right, now we're not going to see the exorcist anymore. We're not going to see all this stuff. When it runs, it's going to stop and print out the values. Oh, good grief. Well, I said it wasn't. Oh, that's because I didn't. What did I do? I made this change here so that it would stop at that, but then I forgot to make another change. In the for loop itself, we need to refer to that length variable, dar underscore size. All right, and then it printed out the contents of the array. So be careful not to use invalid subscripts because it can corrupt memory locations or crash your program or lock up the computer and cause elusive bugs. An off by 1 error is when you try to use a subscript that is invalid by 1. For example, if the size of our array is 100 and so we try to print out elements 1 through 100. Well, that's not going to work. If the array is of length 100, we can print out elements 0 through 99. And so trying to do it as though it were 1 based indexing rather than 0 based indexing gives you an off by 1 error. So here's an example of using the initialization list. We're going to fill in this array with these specific 5 numbers. If this size declarator here is smaller than the initialization list, it'll give you an error because we're trying to copy 5 elements into like a 4-element array. But the opposite's true. It's okay for the size to be larger than the length of the initializer, and if it is, they all just get set to 0 after that. So if an array is initialized with fewer initial values than the size declarator, the remaining elements are set to 0. So we have an array here called numbers. It's set to 7, and we initialized it to the values 1, 2, 4, 8. But that means that the first 4 values are set, but we didn't give any initial starting values for the other 3, and so they just defaulted to 0. The array, if you leave off the size declarator, it can do implicit array sizing, which is where that's picked up from the number of elements in your initialization list. In this case, we have 4. And so if we leave off the size declarator, then it creates an array exactly large enough to hold those 4 values. So a range-based for loop is a loop where instead of using an index for I is equal to 0, I is less than the length of the array, you step through the items by their data type, by their value. Now there's some warnings. This was introduced in C++11, meaning the version that was ratified in 2011. So it's actually a fairly new thing, relatively speaking. Whoa, that was 8 years ago. Yeah, but the C++ language has been around since like 1980. So it's a relatively new thing. Not every version of C++ has been updated to the 2011 standard. So if you're not using Codebase, whatever the Mac version is, the Mac one is called, is it Workbench or Codebase? I don't remember. Or if you're on the PC and you're using Microsoft Windows, then I'm guaranteeing that you've got access to it. But there may be some compiler that you're using. If you bought yourself a Raspberry Pi and you want to write some cool program that'll load your Nintendo games on your Raspberry Pi, it could be that the compiler is not the most modern one, and for each loop, a range-based for loop is not going to work. So each time the loop iterates, it copies the element from the array into a temporary built-in variable. So if your array is called array, then the syntax is like this: for data type space range value colon array. So when we had an array of nums, our data type was int, And this is how we made it look. For every integer value in the nums array, do something. It's a much cleaner syntax. If we have two ways of printing something out, and you can get away with using a range-based for loop, I would do so. When can you do that? If you're in the same context in which the array was allocated. So here's an array of numbers stored in an array called numbers. So the array name is numbers, the data type is int, and so here's a range-based for loop, a for each loop for printing it out. For int value colon numbers. Print out that value followed by E and DL.
So then if you had like if you had a function that returned, I guess, whatever, you couldn't use the range-based for loop for that, right? Because it would be like,
Yeah, if you try to pass this array into a function and then try to use a range-based for loop inside that function, it's not going to work. Yeah. So I want to switch gears and talk about references and pointers for a moment. And even those of y'all who are hurriedly working on your homework rather than following the lecture, I kind of want you to see this. If we define a function and we wanted to change the value of something we pass to it, it's kind of a problem. And this is not true just of this language. It's true of Java, Python, whatever. So for example, I'm going to make a silly function called foo, F-O-O. And it takes a variable, int x, and it sets the value of x equal to 99. And down here in main, I'm going to declare an integer, and I'm going to pass it to the foo function, and then I'm going to print out the value of the integer afterwards. So int mynum equals 0, mynum subscript, foo subscript mynum, and let's print out mynum. Cout error error quote mynum error error quote error error mynum error error endl. And I'm just going to put a system pause here because I don't want to see the rest of the code at this point. If you're on a PC, if you're on a Mac, that's not going to work. All right. It printed out 0. I wanted it to print, well, I thought it was going to print out 99. What happened here? We passed this variable in, mynum, as an argument to fill in this parameter variable here. But it was passed in by copy. It was passed in by values. Like I made a photocopy of my dollar bill and I gave it to you. It doesn't matter if you crumble up the dollar bill or burn it, I still have the original one. X here is just a copy of the 0 that was passed in. And so even when it changes it here, it does not modify the value of mynum at all. However, you can do something known as pass by reference. Pass by reference looks like this. I'm just going to call it void foo2. The way you define a reference variable in this language, and by the way, Java and Python do not have reference variables in this same capacity, reference parameters, is you put an ampersand there. We're saying this is not an integer copy, it's a reference to the original data. And so now, I don't know why I put R there. Why not? Because it's a reference. Nah, I'm going to make it X anyways. X is equal to 88. So now when we come down here, if we called foo2 num rather than foo num, it actually will change it. So it did change it. The ampersand, this is an example. Pass by reference. X is not a copy of the parameter of the argument that was passed in. X is the variable that was passed in. Index is a reference to the argument. It is the argument. For all intents and purposes, whatever you do to this variable happens to this variable. They are one and the same. They are linked by the fact that we pass it in like that. There's another way of passing data in known as pointers. I'm going to show it to you really quickly, and then we're going to talk about pointers again in another lecture. The way that looks is like this. Void foo3. You do ampersand. It's not ampersand. You use an asterisk. And I'm going to call it px there. Just accept it on faith. And then I'm going to say px equals 77, like that. What this is saying is I'm not going to pass you an integer. I'm going to pass you the memory address of the integer. And then he's allowed to change it because he knows the address. Just like if I write down my home address on a piece of paper and give it to you, even though that piece of paper is a copy, you have my home address. You can go and break my windows if you want. So we're passing in the address of whatever variable it is, and then this code can go out and we can modify it. And that's what the syntax means, which we'll explain in more detail next time. Change the value at the address stored in the pointer to 77. But we do have to change the syntax in order to get that to work. We have to do something like this. Foo3, and then to pass a pointer in, I can't just do mynum. I have to turn it into a pointer by putting an ampersand in front of it. Pass the pointer to the mynum variable, to the function. Won't necessarily make sense the first time you see it. The idea of the reference is actually easier to get, I think, right? You just put a special symbol here and all of a sudden it's able to pass data in and out. Any changes made to X inside here modify the original data. Doing pointers is a level of abstraction that we'll talk about one more time. All right, why don't we stop? You're going to also wind up taking the array quiz actually in the quizzes section. But for example, here we have a 4-element array. The first one says F-150, the second one says Corvette, the third one says Citation, and the fourth one says Model T. What is the substring of the element Model T? So what is his index number? Well, what's the index number of the first element? 0, 1, 2, 3. So we put in 3. And then what is the index number of the F-150? 0. And then what is the length of this array? Excuse me, what is the size of the array? If we did size of array, what is it going to tell us? Well, each byte is 4 bytes long. And how long is it? It's 5 elements long. Each element is 4 bytes, so 4 times 5, 20. And then what is the length? 1, 2, 3, 4, 5. And then declare an array called numbers. It is of type double and has 3 elements. And then store element 3.1415 into the last element of the array. I'd expect that by now that we've had a couple lectures, you ought to be able to do that. So that's the homework assignment. I want everybody to be able to look at them as I am. Does this, whoever went into it, does this look like your question 1? All right, so write a function prototype, i.e. don't include a body, a boxy. Hunter, I didn't fix that after you noticed it, of a function that meets the following requirements. The function name is Ummagumma, which if you're a Pink Floyd fan, you'll go, oh, haha. It returns no value at all and accepts a double named D as a parameter. All right, well, what is a prototype? A prototype is a function header, and I did not mean to start idle, not in Python. So what is a prototype? A prototype is a forward definition of a function so that you don't actually have to have the body of the function right there. And the reason prototypes are useful is so that you don't have to declare everything in order, right? We always have an int main, right, somewhere. But what if we wanted to put our function in another file? Or what if we wanted to put our function down underneath, right? Say we had a function called a, for whatever purpose. It's supposed to do something. As is, this would not work. In Java it would. Java is a little bit more generous about the order in which you can put things. Order does not matter in Java. In C++, they matter a great deal. This would be a syntax error. Why? It would go, I have no idea what a is. And so what if, you know, this was supposed to be int x equals a. It needed to take the return value of here, right, return -1, and we would want, when we invoked a, for it to jump down here, process this code, return the value to be stored in x. But the compiler doesn't know what a is. It doesn't know if it needs to pass in any parameters between the parentheses. It doesn't know what its return type is. It knows nothing about it. So we can come up here and add a prototype. And we can say, oh, by the way, you're going to, Mr. Compiler, you're going to run across a reference to a function named a. And here's everything you need to know about it. Now, why didn't we just put this body of the code up here like we've done every other time? Because it might be stored in another file. It might be stored in a DLL library. We might not want to put things in the order so that main is down at the bottom of the code. We might want to put the prototypes in a header and put all of our functions in a different file. So that's what a prototype is. A prototype is a function header without a body that is used to let the compiler know what a function returns, what type of function returns, and what type of arguments, parameters it accepts. That's what a prototype is. So write a function prototype, i.e. don't include epoxy, a body, of a function that meets the following requirements. The function name is ummagumma. Okay, well that makes it easy. I give you a function name. Let's type that, ummagumma. It returns no value at all. Well, something that returns no value is declared in this language as being void. Man, this is noisy. I'm going to drive the listeners at home crazy, as it drives me crazy. And it accepts a double named D as a parameter. Okay, so here's its parameter list. Double space D. It doesn't have a body, so we just end it with a semicolon. Now what would happen in our code if we had this, but we didn't have that? What if we cut that out and we compiled it? It would compile just fine. But then when the linker ran, it would say unknown or could not find a body for this function. Because that function doesn't exist. We've defined it. We've said it exists, but we never actually provided a body for it. So we'd better go and find another CPP file that had it, or we better add it to our code or something to that effect. All right. Write a function prototype that meets the following requirements. Its function name is add3. It returns a double. It accepts 3 doubles as parameters. I want somebody to tell me what to type. Somebody brave. Shelly's up in the front row. I'm going to make you do it. If you don't know, that's okay. What is our function name? Add3, okay. And it returns a double. So what do I need to put in front of it? Double. Yeah. And then it accepts 3 doubles as parameters. So double D1, comma, double. I wish you could just type double D1, comma, D2, comma, D3. But double D1, comma, double D2, comma, double D3. And it's a prototype, so we don't include a body, so we put a semicolon there.
Do we need to add public static? So,
Pardon me, Simon?
do we need to add public static?
If these were methods, yes, but these are just functions. They're not part of a class. So yeah, the question was, is did we need to put public there? Like we saw when we played with classes. No, because these are not part of a class. In some languages, everything is part of a class. In Java and C#, you can't get away with defining a function that's not part of a class. So, yes, huh?
Can you explain the difference between this and not having parentheses? We need to just go add 3 comma D1 comma D2. I'm assuming it's.
That's when we're calling it. You're allowed to, like if I'm going to call this function, let's revise this so that it takes int x, comma, int y, comma, int z. And so our parameter here, I'm going to write a note. I'm going to scrap this one. And we could even do it inside C++. It would not be a bad idea to do so. So I'm going to get Visual Studio going. And I'm sorry to stretch this out. You were probably hoping for the 7-second answer. All right, we're on lecture UVW. That's incredible. By the end of the semester, we're going to have gotten to Y. Too bad we didn't get to Z. We could have felt real proud of that. So new project. Lecture W. Now I'm going to need my boilerplate. I went to a Scottish festival last weekend, and so I must be envious of the people with the cool Scottish accents because I just said something dumb. All right, let's go and actually find my boilerplate, which is on the desktop. Select everything, copy it. I don't see my Solution Explorer, so view Solution Explorer, right-click Source Files, add, new item, lecture W, .cpp, paste. Alrighty, so I'm going to write a function. It was called add3. It takes 3 doubles and returns a double. So double, add3.
Not inside that in there, or
I am so sorry, pardon me.
you're outside it?
I'm trying to mimic this one.
Oh, okay.
Okay, so double add3 and it accepts 3 values, double D1, comma, double D2, comma, double D3. Now that's enough for the prototype. I could just paste this, put it up here above main, and then call it, but it's not going to work because we don't actually have a body. But I could do double result equals add3, 10, comma, 20, comma, 30. And it will compile. If there was a compile option here that compiled just this file, yeah, there is right here. It warns me though, hey, function definition for add3 not found. But it built it. It just can't run because there's no body for that definition. It says unresolved external. And then it gives us a whole bunch of gobbledygook. Double space C decal space add3 double double double. So we do need to create a function that matches those specs. I'm not going to type in that header again if I could just copy it. But I better remove the semicolon after I paste it, or else you're going to get a syntax error. And what does add3 need to do? It just needs to create a variable to hold D1 plus D2 plus D3 and then return it. So double R equals D1 plus D2 plus D3, return R. I don't know why I made it R1. Double R equals D1 plus D2 plus D3, return R. And I should print it out, right? So instead of cout hello world, I'm just going to print out result. And it ought to say 60. Yeah, it did. And I should have put an ENDL. All right, so if you're in the back of the room and my monitor is hiding it, this is the add3 function right there. The prototype goes above main, and it's just a function header without any of this stuff. Excuse me, without the body, so it's just a function header ended terminated by a semicolon. And then here's main that uses it. Okay, so Hunter, was your question, could I not do double D1, comma D2, comma D3, or was it another question?
What's the difference between just doing double add 3, comma D1, comma D2, comma D3 versus?
You wish that it worked that way, and it's just because that's how they made C++. And I can't give you a good reason why they didn't support that.
No, I mean, like, actually removing the double, removing the parentheses, from the double, just saying double add 3, D1, D2, D3. Like, no doubles, parentheses, no parentheses.
Modify your code the way you're suggesting.
Yeah, let me turn. I'm just looking at what the difference is.
Oh, okay. Excellent question. Excellent question. Why do we have all that when we could do this? And the answer is that this does not define a function. It defines variables. So we have an add3 variable, and we've got 3 other variables. These are global variables, by the way, because they're located outside of any function. But it's not a function. And what a function is it's a chunk of code that has a name. And so since I have a function here, it's a chunk of code that has a name that accepts data values as its parameters and it returns a value. If I tried to list it like that, that's not a proper prototype. It's just a list of variables. That kind of makes sense? All right. Very good question. And something that the book will show, which I don't really agree with, is leaving off the variable names in the prototype. And you can do that. You can take the variable names out of the prototype. Now for me, variable names, parameter names, because those are parameter variables, are useful information. Why? What if we had something like this? And it said, you know, void save patient info. And it had a string, and it had another string. Yeah. How am I supposed to know what goes into those strings? I could scroll down and find the function itself. I could read the documentation. But if I had just put, you know, string name and comma, string address, I know a lot more about what that function is going to do. So variable names are useful information that I don't see a reason to leave out of your prototype. But strictly speaking, you can leave those variable names out of the prototype. There's nothing wrong with doing it like this, or doing the add3 the way that I did it. Because all the compiler needs to know is I'm writing something that accepts 3 numbers, 3 doubles as arguments, and so it's going to have 3 parameters, and that it returns a double. That's all the compiler needs to know about it. But humans, we like extra information. We like knowing what the variable names are. At least I do, right? So I could go back and I could add D1, D2, and D3 there. You'll see examples in a book where they don't. All right, so true, false. Every function must have a return type, even if it doesn't return a value. And that's true in this language. In Python, you don't declare return types. You just define a function. And if you feel like returning something, great. And if you don't feel like returning something, great. But every function in C++ or Java or a whole bunch of other languages does have to have a return type. That's why we have the word double in front of our function. If the thing is going to return a value, if it's going to have the return keyword in it, it has to have a return type that matches. That's okay to kind of return the wrong data as long as it can be converted. If I returned an int, it'd be happy to convert it to a double on the way out the door. But if it doesn't need to return anything, you declare it as void. Like if we write a function called say hello, and it says howdy \n. This guy doesn't do anything that we need to know about later, right? We're just telling it to say hello. There's no return statement in it, so we are declaring it as void. Void means it doesn't return anything. If you took fundamentals, the book talks about having a fruitful function and a void function. That's or a fruitful module and a void module. I forget the terminology in that textbook. It's module, I'm pretty sure. Well, here's a fruitful one because it does return something. And here's a void one because it doesn't. So every function must have a return type. If the function is not going to return anything, declare it as void. Alrighty. Well, guess what the next question is? Tell me if it's true or false. The return type for a function that doesn't return any value is null. Now, honestly, that sounds true. If I was taking this quiz off the top of my head without having seen it, I mean, I wrote it, I would probably check true. The reason I would probably check true is you Python programmers may know that if a function doesn't return anything, it actually does return a special value of none. So if you write a function like this in Python, and all it does is nothing, right? It doesn't do anything. It just has a return statement. And then if you did x is equal to a, and you printed out x, it would say none. But C++ doesn't do that. If it doesn't return anything, it really means, okay, what am I talking about? The return type for a function that doesn't return any value is not null. I just said what it was. It's void. Where'd my source code go? Right. So that is a false answer. It's tempting to say true because we've seen the word null in here, and there. Null meaning empty, right? Void meaning empty. Void. We declare it as void. So that's a big false. Oh, and look at that. Questions 4 and 5 are identical. Tricky. Describe briefly what a prototype is and why you would use one. I should make y'all do that. I've already stated it. A prototype is a definition of a function that includes its name, its return type, and its parameter list. And you can have an empty parameter list, right? Nothing between the parentheses. But no body. Why would you use one? I've kind of explained it, but somebody take a shot at explaining back to me. Simon, why would I use a prototype? Exactly. It's so that we don't have to worry about the order in which the functions are declared. We could put the function below the main or in another file. So the prototype allows us to put the function itself in another file or below where it is called. The book may have a slightly different explanation, of course, but mine's better. No, I'm kidding. Right, but that's the gist of it. Alrighty, the next one, true or false? Now I'm kind of in a rut. A lot of my true false questions, more often than not, the answer is true, just because I hate writing false statements. But if it's a whole bunch of check boxes, right, and you have to click the true ones, then of course there's going to be some false ones as well. So this is true, but why? True or false? Prototypes should be placed near the top of the program or in a header file. Well, what use are they if we stick them at the bottom of the file? That's like just declaring a whole bunch of variables at the bottom of main. I'm not going to use them. If we stuck the prototypes at the bottom of the file, they're of no use. So prototypes to be of use should be put near the top or in a header file that you include. Match the term with its description. Well, let's lecture about it before we answer the question. You see this variable here, D1, and you see this number here, 10. Those are two completely different things. This is called an argument. When you pass data into a function, you give it arguments. Sounds bad. Don't give me no lip. I don't want to argue with you. We give it arguments, and the arguments fill in the parameter variables, or parameters for short. So the parameters are the things that are defined as part of the function header, and the arguments are what you pass that fill in the parameters. Let's go look at the test question again. So a variable in a function that holds a value passed in by the function call. Is that going to be 1 or 2? Or, well, maybe yours are randomized. Is a variable that holds a value passed into the function, is that an argument or a parameter? That's a parameter, exactly. And then the value passed in is an argument. Now that's true no matter whether the argument, the value that's passed in is another variable or not. I'll go back in and I'll give it an example of that. What if I declare a variable called my age for whatever purpose, and I stick 100 in it? And then I pass in my age as an argument. It bugs people at first, some people, that this variable doesn't have the same name as that. But they're completely different things. This is a receptacle for that. This gets a photocopy of the data because it's a pass by copy language unless you do something and declare something as a reference or a pointer. So this does not have to be the same name as this at all. And if you make a change to this, it doesn't touch 100. If we went down here and we said D1 equals 0, then my age after this function call is done is still going to equal 100 because it just gets a copy of it. It doesn't bother people if we pass in data and it doesn't match the name, right? But, and I understand, a lot of people want to see that variable name equal that variable name, and they absolutely do not have to. They are two completely different things. This is something that provides a value to be copied into here. Now, Rochelle and I are two different people. We don't have to have the same name just because I'm going to give her a copy of my book. I think we're not the same person. No, we're not. Alrighty. So, match the following parameter types with their description. Alrighty then. We lectured about this for about 10 minutes. Last class period. Who can summon it up into their brain? Which one of these is a pass by pointer? And if you don't even remember what a pointer is, that's okay because we're going to talk about it again. It's the second one. If you see an asterisk in its declaration, it's a pointer. You're going, what's a pointer? I've slept since improv. Well, we'll cover it. And then pass by reference. Ampersand. Pass by value. It's just the normal one with no special declarations at all. Java and Python do not support either one of these other things, pass by pointer or pass by reference. A lot of languages don't. Alrighty, which of the following statements are true? No, more than one is. A function may have only one return statement. I'm going to skip that one. Well, okay, great. This one's just the opposite. A function may have more than one return statement, so don't click both. A function must include a return statement even if it is declared as void. Well, let's go and look at my code. I had something called howdy. It does not have a return. Doesn't need one. Some editors will even give a warning if you put the word return there, which I think is obnoxious because it's a purely acceptable. It's totally acceptable to put the word return there, but it's not necessary. So, in our little quiz here, a function must include a return even if it's void? No, return is optional if it's declared as void. A return statement can be used to pass a value back to the code that calls a function. Well, yeah, that's the entire reason for it. The return statement needs to pass a value back, and then the code's going to use it, like this one, right? He returns R so that we can store it and use it. Otherwise, why bother returning it? It's perfectly legal to call a function and not retrieve its return value. It's like you went to the store and you bought me some milk and I just go thanks and I walk away without taking the milk. It's kind of stupid, but yeah, it can. So that one is definitely true. A return statement can be used to pass a value back to the code that calls the function. It ought to be worded even more emphatically. A return statement is used to pass a value back, or a return statement passes a value back. All right, a function may have only one return statement, and that's absolutely false. We can put 20 return statements in it if it's a long function. But, you know, what if I'm just going to create a silly function down here, void, or no, it needs to be something with, you know, int, silly. And then I could make some kind of condition, ask the user for something, you know, cout, enter a number, and then we could do some dumb stuff like this. CIN into a variable. I think I'm just going to wind up deleting this. We're not going to actually call it, but I guess I'll make it valid code anyways. CIN into x, and then if parentheses x is equal to 1, then for some reason we're going to return 100. If x is equal to 2, we're going to return 1,000, 10,000, whatever. If x is equal to 3, we're going to return 100,000. And if none of those things are true, then we're going to return a -1. Right? We have lots of return statements in there, and it's valid code. It'll compile. Why we're returning 100, 10,000, and 100,000, I don't know, but it's perfectly valid to have
What would
multiple.
you have to write to get -1? Nothing? Then how do you like write nothing? You know what I'm talking about.
Not yet. I don't know what you mean.
So what would you type? Would you just put a space and just click enter to get the -1?
Well, if I wanted to see the -1, I could enter something other than a 1, 2, or 3. I could type in a 4 or a 0 or anything else. Yeah, good question. Good question. And maybe I should have written this as if, else, else. Right? I see exactly why you asked your question. What if I had written it like this? It'd look a little bit better. Else if, and then lastly, else, not else return -1. That makes it pretty clear how it's going to work. Being just a little bit too clever by sticking everything on one line and not putting else's.
Sorry.
No. All right. So a function may have only one return statement? Nope, that's false. A function may have more than one return statement? Another example of that, and I'm not going to actually put it in the code, would be something like this. You know,
That's your button.
int save to file. We try to open the file, right? OF stream, whatever equals open, right, file name. And if that fails, if not whatever, return an error code. else do something, right? Keep going. And so we could have a whole bunch of code and have a different return value at the bottom. And then when we call save to file, we could check its return code. And if it returned a -1 or a -2 or a -3, we would know it failed. And if it returned a 0, we would know that it succeeded. That is a common programming motif where you make functions return zeros to indicate no errors, and you make them return other values to make them indicate that it's an error. Now, why wouldn't you do the opposite? Why wouldn't you make 0 an error? Because that only lets you dictate one kind of error, right? You might want to dictate a whole bunch of different kinds of errors. So you make 0 the success. Even though that's kind of backwards from that true-false thing, where a 1 is a true and a 0 is a false. 3 statements are true. Oh, well, look at that bad writing. Non-static local variables only exist. But that almost sounds like Zen or Buddhism or something. I don't even know what that means. And I'm the professor. All right, let's go on to the other ones. I need to modify that question. Static local variables retain their contents between function calls. Well, we haven't even talked about static variables yet, so how can we answer these questions? The scope of a global variable is the portion of the program from the variable definition to the end of the CPP file. Somebody just hazard a guess as to whether that sounds good or not, and it's totally okay when you get it wrong. Does that sound good? What's the scope of a global variable? The scope of the global variable is, in fact, from the point where you define it to the bottom of the file. Like if I put a function, a variable here, int Fred equals -1, I'm not going to be able to access Fred here or access Fred up in main. His scope, the place where he is visible, is from where he is declared all the way to the end of the file. And there's no way to declare a variable prototype. So you just have to have the variable declared above where it's going to be used. Something's nagging at me about that statement, and I can't figure out what. So I'm going to pretend that what I just said is true. The scope of a global variable is the portion from where it's defined to the end of the file. Now, if it was a local variable, that's not true. What is a local variable? It's one that's declared inside a function, like R. What is his scope? His scope is not to the end of the file. It's limited to the close brace, right? We can only get a hold of R from here to here. That's why we're returning it. Otherwise, we wouldn't be able to get a hold of it at all. So a local variable scope is only for the rest of the function, or to the close brace in which it was defined. A local variable is available to every function in the CPP file. Now, I just kind of stated that we're using different terms. Is that true or false? Is a local variable available to every function in the file?
False.
Yeah, it's false. And a local variable is a variable defined outside of the functions.
False.
That's false because it's a global variable if it's outside of the functions. And this is just true. I'm going to say it before we read it. Global variables are automatically initialized to 0 or null, whereas local variables must be initialized by the programmer. For some reason, that's true. I'm not strictly sure why it would be a bad idea for the compiler to go ahead and initialize, local variables, but it doesn't. So that is true. Global variables are initialized to 0 or null, which is the same thing as a 0, or false if it's a Boolean variable. But they're all the same kind of thing. A 0 is a false, is a null. All righty. Static variables retain their contents between function calls, and non-static local variables only exist. I'm going to have to look that one up just so that we can give ourselves the correct answer. I'll look it up in a minute. All righty. We haven't talked about it, so I haven't said whether B is true or false. I'll go ahead and say it's true, though. The word static means something different than it does to the Java programmers. In some ways, it means the same thing, but in some ways, it means something completely different. Select the most correct statement about this. String name is equal to Bob. Is Bob an array? It sure does look like one. Because we said that something between quotes is an array. I'm really not liking this question because I would argue strenuously that it is, and I know that it's probably not. Bob is a global variable. Heck no. Bob is a default value. That is true. Bob is a prototype. No. Say hello would be the prototype if it ended in a semicolon.
Can you
Oh.
quickly remind what is the default value?
Not something we're expected to know until we've lectured about it. And so, just like static variables, we're going to have to talk about it.
Got it.
Let's do it. Let's talk about it. We have this say hello function right here. I don't know if you typed it in, but what if I decide I want to be able to say hello to somebody? String name. Equals, quote, Fred, end quote. And then our howdy message is going to say cout error error quote howdy end space end quote error error name error error endl. What this means is that if we call it and we don't put anything between the parentheses, the name variable still exists and it gets filled in with Fred. Go ahead and cut that and paste it above main just so we can play with it. And yeah, we could just define a prototype for it, but I want to go ahead and do it this way, please. Just come up there and paste that function above main, and we're going to play with it. Say hello to my little friend. Or say hello with nothing. If we did not have this Fred here, that second one would be a syntax error. Like that. You see a little bit of the error indicator there. Too few arguments in function call. That's because we have a parameter here and we're not passing it a value. We could fix that by passing in a value. We could pass in an empty string or something like that. Or we could put in a default value. Default name equals Fred. So if we do not give it a value, when we invoke it, if we don't provide an argument, what is that statement? If you can't afford a lawyer, one will be, provided for you. Well, if we can't provide an argument, then one will be provided for us.
So is that going to say howdy?
This one's going to say, howdy to my little friend.
Fred.
And then this one is going to say, howdy, Fred. Let's run and prove that.
Right.
All right. Howdy to my little friend and howdy, Fred. Because the first time we did provide an argument that gives this parameter variable a name. The second time we did not provide an argument, and so it accepted the default value, otherwise known as a default parameter. Does that make sense? That makes sense. We'll probably hit it again when you get the PowerPoint itself. On Tuesday. All right, so let's see if that's true. Bob is a default value. What is sneaky about this is that something declared between quotes and it's a series of letters is actually a character array. So if you answered A, then I should have to give you credit for it. But we all know, just to save time, why don't we go ahead and pick C, or whatever order they're in on yours. Two things I need to fix. Three things. I don't like it saying boxy. I don't like it saying non-static variables locally only exist. And that one. So questions 11, 12, and 1. I can't believe I've had this quiz out for like 8 years and not fixed it.
8 years?
I've been teaching for that a long time. 1, 11, and 12. I started off as an adjunct, though. I had a real job until I became a professor. Okay, so I was a programmer. I programmed for a company in Stillwater, and then they were bought out by a French company, and I didn't want to move to France
Why not?
to be near my parents. Isn't that the stupidest reason? No, I'm kidding. I should have taken them up on it. I should have gone to France. And so I went to Enid, and then they were bought out by another company, and I didn't feel like moving to Wisconsin. We just had a kid. We just had a kid. We didn't feel like uprooting ourselves. And so we stayed in Enid, and then finally we decided to move to Midwest City, and I decided I'd rather be a teacher. I like teaching. It's my calling. Okay, so what is a static variable? And since this is true, that one has to be false, no matter what gobbledygook it is, because it says 3 statements are true. So what is a static variable? Well, let's find a non-static variable. Let's make up a non-static variable. We have this method here called say hello. Let's make a new one. Just call it test. Make it really vague. And we're going to declare a variable called x and set it equal to 0. And then we're going to add 1 to x plus plus. And then we're going to see out a message that says in test x equals, end quote, arrow, arrow, x, arrow, arrow, e, and d. Now in main, let's call test like 3 or 4 times. Test, test, test. Oh, and I also worked for the state for a while, and I should have stayed there because that's job security forever, even though you don't get paid anything. Nah. Alrighty. So, what is it going to print? It's just going to print 111. 111. And how I got my start is I was hired in an IT department to do maintenance programming and customer support. That's a very common thing. Common first programming job. Pardon me? So I run it. 111. Why is it 1? Because this variable keeps getting reset to 0. Every time we call test, it gets reset to 0. And you think to yourself, okay, well, what if I didn't give it a value? Ain't no way that's going to get reset. Instead, it just doesn't work. You have to initialize a variable before you can use it, unless it was declared as a global variable. We could conceivably move this out, make it a global variable, and then everything would work a little bit differently. Like I could cut this, paste it, make it a global variable. I might give it an initial value, otherwise it would default to 0. Global variables automatically default to 0. And now when I run it, it says 1, 2, 3. Why? Because nothing is resetting it back to 0. And maybe that's a real good thing. Probably is a real good thing. Otherwise, why would you be making it a global? But the problem with making it a global is any function can get a hold of it. Right? Main could get a hold of it. Down here, I could change the value of x. I could say x is equal to 20. And then when I ran it, it's going to print out 1, 2, 21. Now maybe that's what I want. Maybe I want the ability to secretly go in and change the value out from under the feet of this function. Since it's a global variable, that's kind of what is implied. Uh-huh.
So how would you allow it not to reset every time?
That's what we're leading up to. And the answer is a static keyword. So we have the ability to make it a global variable. That is one way to solve the problem. The other is to move it back in here, but call it static. And by the way, since it's now defined in that function, I can't get a hold of it here anymore because it's local to that function. So this line is an error. I have to delete that x is equal to 20. So that data is safe. Nobody else can get to it to change it. It's this function's property. So it's safe and sound, and it does not get reset to 0. 1, 2, 3. So that's what the static keyword does, is it defines a variable that does not reset each time. It does not lose its value when the function exits. In effect, it is a global variable that's only accessible inside that function. It is stored outside of the function. It's stored in the same place that global variables are stored. It's just that you can't get a hold of them. And you Java programmers are going, well, that's a different usage of the term static than what we used it for in our class, and that's true.
So why not use const instead of static?
Const means it can't change. Right, if we make that const, then this is a syntax error. Const means, oh, once you have a value, you better not change, which is kind of like the complete opposite. You make a static variable so it can change,
So it can change.
but maintain its value. Okay, so non-static local variables only exist. Don't choose that one wherever it is. Static variables retain their contents between function calls, or they are not erased when the function leaves, exits. That's a way to say it. A local variable is available to every function in a CPP file. Not true. A local variable is any variable defined outside all the functions. That's not true. That's a global variable, and global variables are automatically initialized to 0 if no initial value is provided. So those are our true ones. I hoped I earned 100 on my quiz. I'm seeing lots of 0 points here. I failed my quiz. No, I'm kidding. But I made an 85. Did anybody score above an 85? Is the preview function wigging out on me, or did everybody get an 85?
Wait, was the one with void wrong on your screen?
Yeah. Okay, this one had to be graded by hand, so I'm not surprised that that one gave me a 0. Every function must have a return type. Yep, that's true. I got my point there. True or false, the return type for a function that doesn't return any value is null. That's false. The return type for a function that doesn't return, okay, I thought it was a duplicate question.
No.
It's not a duplicate question, and I should have chose true. I'm sorry I didn't catch that before everybody submitted it. And then this one had to be graded by hand as well.
So you'll grade zeros by hand?
I'll go in and I'll give everybody 100, because I told you this is false because I said it was, you know, a duplicate question, but it's not, because that's definitely a true statement. It's a good idea to take the exam a second time, the quiz a second time, right? Good prep.
It doesn't really tell you what you got though.
Well, when I scroll down to the bottom, it did, but that's because I'm a professor. Yours hasn't been graded yet, so it doesn't tell you. Is that true? If it was all true, false, and multiple choice, it could tell you. But since I haven't graded the pieces that have to be graded by hand, it won't tell you. But I'll do that tonight so you can eyeball it. Why don't we go and look at the Chapter 7 quiz? We have lectured a lot over Chapter 7. Let's see if we know enough to feel comfy about it. Y'all like this, right? You like going over the quizzes like this?
Yep.
I hope so.
And not because of the grade, but because we understand it better.
Yeah, we get to talk about it a lot.
Yeah.
That's why I like it. And I know secretly it's because you like the grade. No, I'm kidding. I'm teasing. I'm teasing.
I mean, doesn't hurt.
Doesn't hurt. All righty. So, which of the following statements are true? Now, I'm expecting y'all to be able to answer these questions for me. If I see something that I don't think we've covered, or that you see something you don't think we've covered, that's fine. But is an array a variable that can hold multiple values of the same type? Does that sound good? Wave your hand if you agree with her, Shelley, because she's correct. All right. If you declare an array of ints, you can also store strings in there. And that sounds kind of hinky. And no, once you declare an array as an array of ints, that's all you can put in it. Or some data that's compatible with ints. Once you allocate an array, its size will grow and shrink as you add data to it. Nope, that's a Python list or a C++ vector or a Java array list. So that's false. Don't be fooled by the fact that I clicked it. It's false. Yours are probably in random order, right?
Yeah.
All right. Values of an array in C++ are stored in adjacent memory locations.
Yeah.
That's absolutely true. That's why they're awesome. They're awesomely fast because they're all just right there in a row. And arrays are declared using square braces. I could have been mean and said that they are declared using, something else like curly braces. And then maybe you would have looked at it and thought they were square braces, but I wasn't trying to be a jerk. Now, it's interesting that I made something with 4 true statements and only 1 false. Usually I try to balance it a little more than that. All righty. We've done this. I want somebody to tell me how to do this.
Int.
Yeah, write a line of code that declares an array of type int. Well, that's a good hint.
What's the difference between that and constant? I keep getting that mixed up.
Const means it can't change. Right, so you create const name equals Fred. Well, it's never going to change. I can't fill it in. I can't let the user type in anything else. Does that make sense? Yeah, that's what const does. And so, what's the name of the array? Tests. It should be 5 elements long. Square brackets 5. And don't use an initialization list. Don't forget the semicolon. If you forget the semicolon, it counts you wrong and I have to go back and give you the point. If I was a jerk, I'd count you wrong for leaving the semicolon, but I'm not. Well, I mean, I may be a jerk, but not for that reason. Write a line of code that will declare an array of type string. All right, the array should be called colors and use an initializer list. And oh, by the way, don't specify the length of the array. Let the initializer handle it. All righty, so somebody tell me what to do here.
String colors.
Yep, string, space colors. Now I forgot something maybe. I need something that's going to tell me that it's an array. Because right now it just looks like a string, like I could do that. It's not an array, it's a variable. I need to mark it as being an array. How do I do that? I put square braces. Right. Equals, and now I put my initializer list, and I was so kind that I even gave you the syntax for it. Curly braces, double quotes, and all that, so you could just copy and paste that.
Oh, right. Why not?
There we go. True or false? This code will initialize every element in scores array to 0.0. Now, I've talked about using an initializer and putting only one value in it. If I put one value in the initializer list, what it does is it sets the first value in the array, the first element in the array to that value, and then it leaves the rest of them 0. So does this sound good as a true or false question?
Because the rest is going to be 0 without the point 0 at the end.
Okay, I could start to argue that it's false because it's going to initialize the first element to 0.0 and then it's going to initialize the rest of them just to 0. But for a double, they're the same thing. So I would say that's a true statement, and if somebody wants to tell me why it's not true, I'm certainly pleased to repeat why. I mean, is that an okay answer? Do we agree now that I've stated it that way, or who said it was false? Yeah, so how come? Okay, you understand? Okay, so yeah, it's definitely a true statement. This is how you initialize everything in an array to 0.
Is this purely for double? Or
No, for int, floats, longs, whatever. And really what it is that it's setting the first value equal to 0.0, and then it's setting the rest of them to 0. If our syntax looked like this, remind me not to save all these changes in my boilerplate. If I did something like this, int x 100 equals 1 comma 56 comma 98, like that, then what happens is x subscript 0 is equal to 1, x subscript 1 is equal to 56, x subscript 2 is equal to 98, and then all the rest of them are set to 0. x3 through, what's the last element we can access here? 99 is the last element. So x3 through x subscript 99 are all left 0 because they were not given any values in this initializer list.
Can I just write that? Okay.
All right, which of the following statements would print the first element? Scores 1, scores 10, scores 0, or scores 9 if the array is declared. Well, it doesn't matter how it's declared. The first element is going to be which one? Say it out loud. Bold. Outside voice. 0. All right. Which of the following statements would print the last element? Well, if it's linked 10, that means the last element's going to be 9. What would be a good way to calculate the number of elements in an array of ints called scores? These may be randomized for you. Size of scores divided by size of int. Whoops, that's a multiply. I'm not digging the multiplication there. I think the way to calculate the number of elements is to take the size of the array, dividing it by the size of the elements. So asterisk looks like a wrong thing. How about size of scores divided by size of int? Does that seem like a good way to calculate it? Since it is an array of ints, yeah, that'll do it. How about size of int divided by size of scores? Well, that's like trying to calculate your average by saying I have 3 scores and each one was 100, so I'm going to divide 3 by 100. That's not my average, right? It's 100 divided by 3. You want the big number divided by the little number. The big number is going to be the size of the array, and the little number is going to be the size of the element. So that's not right. Those are swapped. And how about size of int times size of scores? Okay, the fact that it's multiple choice kind of indicates that it's wrong, but why is that one wrong? It's multiplication, and you do division to calculate the size. Right, if you had a train and you knew that 100 people were in the train and you knew that each train car held 4 people, nah, that's silly. Each train car held 25 people, how would you figure out how many cars were in the train? 100 people divided by 25 people. Same with arrays. The array is 100 bytes long, and you know that it's containing ints. Well, 100 divided by the size of an int is how many ints there are. And who remembers how many bytes are in an int? Yeah, 4. Alrighty, so if you have this array, what's a good way to print it? You know what, this kind of thing is almost worse than just asking somebody to write the code to print it, because your eyes start to cross. And they're probably in random order. But somebody staring at this, if I can zoom in, tell me if this will print out the array. For integer x, :ia, print x. Are you feeling good about that one? Yeah, for each x in the array, print x. That is correct. That is a good one. So somebody, okay. I'm going to skip this one. I'm going to come to this one. I'm going to look at D now on my list, not yours. For I equals 0, I less than num, I plus plus, print I. What is that going to print? Does it even have any mention of the array?
0 to 9, but also it says I less than, so I'm not sure if that's valid code.
Yeah, that's completely valid. It's completely invalid. As a matter of fact, all of these with the less than should not be counted as correct. Guess what? Professor has to fix that. All right, we're going to pretend that those are single equal signs. But this one's not valid because if it was not a syntax error, it would print 0 through 9. How about this one? I equals 0, I is less than num, I plus plus, print out IA. That's just going to print out, yeah, it's just going to print out the memory address of IA. This language would not automatically convert it to the contents, unlike some other kinder languages. So that one's not good. You don't want to just print out IA. Instead, you want to print out IA subscript I. Now that's nice because we have an index counter going from 0 to 9. Print out array element I. That's perfectly good. Other than that, less than. And this last one. This has got the same problem that the one above it has. For every integer x in IA, print out IA. Nah, what do we want to print out? How would we fix statement F? Yeah, just delete the IA and replace it with an X. Right? If that was gone and it was X, it would be a good loop. Because that's what this means. For every X inside IA, for every integer inside IA, print that integer out, stored in X. So that's bad. Now, I skipped this one. We're going to go way back to it now. I mentioned this on Tuesday as being the wrong way to print out an array. What's wrong with this one? IAX, IA subscript X. That looks like a good way of accessing an array, right? But it's not. And why is that? Because this is a for each loop. Who knows what numbers are stored in the array? It could be 10,000, comma, 10,001, comma, 10,002. And in that case, is IA subscript 10,000 going to be a good idea? If the array is only 10 elements long, then printing out IA subscript 10,000 would be a very bad thing. So if you're going to use the for each syntax, you just print out the variable itself. If you're going to be using an index-based loop, go ahead and use the variable followed by the subscript. That makes sense? Somebody give me some bold, assertive thumbs up, or do we need to lecture about that? Which is okay, I'm happy to talk. I see one thumbs up from somebody in the advanced Java class, so I want to see some other thumbs up. You good? You good? Ever, alrighty. Parallel arrays. Did we not talk about parallel arrays? I'm pretty sure I have said that what is a parallel array? It's two arrays of the same length. Does that sound familiar? Mm-hmm. Okay. So parallel arrays should be of different lengths. No, parallel arrays are of the same length. Why don't we just give the definition and then work backward to answer the true-false questions? Parallel arrays are two or more arrays of the same length that hold related data or hold data where Hold data where the elements are linked by their index numbers or by their subscripts. Where the elements are related by their subscripts. So we have string names equals Joe, end quote, comma, quote, Bob, end quote, comma, Sam, end quote. And then we have int ages equals 12, comma, 14, 15, comma, 13. So what index number is Joe?
Oh,
Not his age, but yeah. Yeah. So what's his index number? What's his subscript?
oh, 0.
0. And so the ages subscript is 12. So Joe is 12. Bob and 15 are both at index 1. So the elements are related by their subscripts. They're linked by their subscripts. Conceptually linked by their subscripts. So parallel arrays should not be of different lengths. Are parallel arrays 2 or more arrays that contain related data? Yeah. How about parallel arrays may be of different types? Well, if we just look at my example, are these of the same type?
No.
No, they could have been if, like, they were first name and last name, but they weren't. They don't have to be. And to use parallel arrays, elements of the same subscript are related. And yeah, that's true. If it is unknown how much data an array will be holding, you may winding up using a partially filled array. I mentioned partially filled arrays. Okay, so this is just flat out a true statement. This is not true false. If you don't know how much data is in the array, it can be a partially filled array. You have an array called scores. You don't know whether there's 0 scores in it or 100 or somewhere in between. So if we have a partially filled array, it's implying that maybe there's some data in it, but it may not be full. So which is true? Should we make the array large enough to hold the largest expected number of elements? Yeah, if there's going to be 10 homework scores for the semester, I better not make the array only 5. So I don't know if this is randomly sorted for you, but that's definitely a true statement. The array should be large enough to hold the largest expected number. Now you can get overzealous. If I'm trying to keep track of the number of students who are going to rows, I don't need to declare the array to be 10 million elements long. We don't have quite that many students. Using a counter variable to keep track of the number of items stored in the array. Oh, well, that gives it away. Yes, you use a counter, right? And the counter says, oh, there's no data in the array, or there's 10 items in the array, or there's 100. And then when you process the array, you should go from the beginning to the end, ignoring the counter variable. That's not true. Alrighty, we don't have enough time to answer all these questions, so I guess I'm going to give you the answers, or we could just leave the quiz unsubmitted. But why don't I give you the answers, and then we will lecture about why they are true next time. So a nested loop is not a valid way to access the data in a two-dimensional array. Well, we didn't get far enough into the chapter to know what a 2D array is. But a nested loop is absolutely how you do it. There's really no other way. So that's not true. A two-dimensional array declared as 4 by 3 will have 7 elements. No, if you have an Excel spreadsheet that's 4 by 3, how many elements are in it? 12. You multiply them. A loop is a good way to compare two arrays. Yeah, that's true. To compare two arrays, you must compare the arrays element by element. And yeah, that's true, right? If you have two lists and you want to see, whether both lists contain the same names, you have to look at one, you have to look at the other, and you have to, be looking at each one. So you have to compare element by element. And in a two-dimensional array, 4 by 3 will have 12. All right, so again, we had too many true answers. More than one being true, oh boy howdy, 4 of them were true. All right, and then lastly, is this an example of a range-based for loop? Somebody tell me if this is a range-based for loop, which we were also calling a for each. That's definitely true. If it was for int I equals 0, I less than blah, 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 it would be an index-based for loop. Alrighty, so I'm going to have to go back and lecture about those 3, but we were running out of question. Ooh, look at this. It's saying I got something wrong. An array is a variable that can hold multiple values of the same type. But that can't be wrong. If you declare an array of ints, you can store strings in it. Oh, I checked that and it's not true. I hope you didn't check that. I said it wasn't true, and then apparently I clicked it anyways. You may have to take the quiz again if you're not getting all these right, which you can't tell. Right? Like I said, I'll go through them, I'll grade them tonight, and then you can eyeball them. Once you allocate an array, okay, that has to be the one that's wrong. We got that one right. Write a line of code that has to be graded by hand. We got that one right. We got that one right. Didn't get that one right. Didn't get that one right. Got that one right. Ooh. Professor failed the exam here. You got another one
I
wrong.
don't think I saw you clicking all of them, to be honest.
I did not select all of these.
No, you didn't.
All right. It's flaking out. All right. Yeah, and I know I did not select 7.
Yeah.
All right, so, okay. All right. Definitely take it again, especially after we lecture about the last few questions on Tuesday. So what are we going to do next? We're going to lecture more about functions. I think we're pretty good on the functions. There was only a couple of topics that we didn't know, but we have to, brush up on them, finish that one, and then we need to finish Chapter 7, which is not going to take like more than 10 minutes to cover that topic. It's just that we've run out of time, and I don't want to keep y'all past 11:22. All right, we didn't have a homework. Excuse me, we didn't have a lecture to upload, so we're good there. I don't think it's appropriate to assign a homework assignment just after doing a whole bunch of quizzes. So I think we're done. I don't see anything we need to upload.
No. The lecture W.
Oh, did y'all type in notes?
Yeah.
Okay, well, we can make a Dropbox, but if you don't upload anything into it, I'm not going to count off because not everybody took notes. Oh, you're right. We typed in Visual Studio Notes. What am I flaking out on? All righty. All right, there's a Dropbox there. W. All right, I don't have to leave immediately, so if you have questions over homework and stuff. And by the way, it was pointed out to me that you could not get a hold of the assignment for that the attachment wasn't visible. You'd click on it and get an error message. And that's really irksome because if you went to content, you can open it there, but not everybody goes and looks at the content homework page. So I think it was a simple arrays assignment. I'm extending the due date on it since people couldn't open the attachment if they didn't go to, unless they went to the content page. But we got a lot of submissions for it. Thank y'all. All right. Sure, nobody wants to stay and play with homework?
I've got one.
I'm sad. Yay! All right.